So getting into hyperskins with Aleksandar, we'll be using Autodesk Maya to model body architecture in a sense, let's say. So quick introduction is Aleksandar is a designer at Heatherwick and received his undergraduate and MArch at the University of Belgrade. Following this experience, he joined the Architectural Association Design Research Lab, AADRL, in London, where he received his MArch II in Architecture and Urbanism. After graduating in 2016, he joined an experimental studio, Somianham Design, where he focused on simulation and digital fabrication, and Zahadid Architects. As a designer for Heatherwick, he is working across all scales of projects, from concept to schematic design. And of course, tutor at the DRL is working closely with students on simulation-driven digital workflows centered around programmable materiality. And as well as I mentioned before, a educator in our master's program as well. So before I hand it over, please remember that if you would like to chat, please switch your chat to everyone so that you're not just writing to us. And if you have any questions during the webinar, please use the Q&A button. If you look at where all the Zoom buttons are, there's one that says Q&A. If you click that, you can ask questions there. It just makes it easier to keep track of. Yeah, I'll hand it over to you now.
Thanks, Mike, for the introduction. So guys, we're going to do a little bit of a continuation of the first Hyperskins webinar, and we'll, as Mike already introduced, be using Maya. So without further ado, let's just dive in. I'm going to share my screen. Mike, is everything working okay? You can see the screen?
Yep, seeing it fine.
Perfect. Okay, so because as Mike sort of introduced, this webinar will be covering something more along the lines of body architecture. We will start by using a pre-made mesh in Maya, which will be located in your sculpting ribbon. And then you can open up your content browser, which is this little browser with different meshes and different examples really of everything that you're using in Maya. Basically, any kind of subcategory within Maya, there's an example here that you can pull out, whether it's FX, modeling, animation, or anything like that. By default, it leads us to modeling, and we need to navigate to bipeds because that's what humans technically are. And then we can just drop in one of the human bodies, whichever takes your fancy. I will use this one. So you need to just left click it and drag it into your scene in order to populate it in. We can close the content browser then, and then zoom out by scrolling. With Alt and middle click, we can pan and just take a look at the model that we have in the scene. By default, it will have this blend material on it. I usually personally just select it and then hold down right click to change the material and navigate down to assigning an existing material. And you can just put Lambert on. This is a base mesh that's already part of every Maya package. You should be able to get it regardless of which Maya version you have. And it's a pretty clean mesh in terms of modeling and the topology that it has. We're going to use it as a base. So in our outliner, which should be on the left-hand side, we can double click its current name and let's just call it base with all capitals. I will duplicate it by pressing Control D. And then by selecting the original mesh and pressing Control H, we can hide it away. It will be grayed out in your outliner and invisible in your viewport. And now we're going to perform some operations on this mesh to retopologize it in order to get a good working base for modeling and simulation of the suits that we're going to be working on. So for the first one, I'm going to step into edge mode by hovering over the object, holding down right click and then choosing edge. We're going to select all of the edges that are available to us. Then hold down space, go to create, and go to sets and create a set. This set will basically create a current selection of the edges that we have and save them out. We can then step back into face mode by holding down right click while hovering above the object and stepping into face. And by double clicking on any face, you will actually select the entire shell, meaning all the faces that are connected together. Then by holding down space and going to mesh, you can go to triangulate. Triangulation basically adds a slash inside of each face that corresponds with the triangulation pattern of the mesh. And because this mesh is clean, the triangulation pattern itself is also quite nice and symmetrical. So what we want to do now is step back to object mode, deselect our object, and navigate back to our outliner. In our outliner and our set, we'll have the original edges saved. And if we right click the set and then select set members, they will become highlighted. What we are aiming for, or what we're interested in basically, is this a nicer pattern, or like more, let's say, interesting pattern than the quad mesh that we have by default. So by stepping into edge mode and reversing the selection, so you can either reverse by going to select and inverse, or you can use the hotkeys of Control Shift and I. So I will use hotkeys, Control Shift and I together will get us the other direction of the pattern. And this pattern we're going to detach. So if you hold down space and go to Edit Mesh, you can detach. Seemingly nothing will have happened. The mesh will look the same, but we can display it in a different way that shows us the naked edges, because the edges that we've just detached are no longer connecting the adjacent faces. So you can step back into object mode, select your object, press space, go to display, navigate to polygons, and then in this drop-down menu, go all the way down where it says custom polygon display and open this little dialog box that shows a little square. So what we want to be on is the soft and hard option for the edges. And we want to highlight the border edges with an edge width of 2. If this is not already set this way in your dialog box, this is how you should set it up. And then when you apply, you will actually see that all of the naked edges are being highlighted. So you can close this dialog box and take a look at your mesh. Even though this is a really quick way of getting a pattern, is not strictly speaking the cleanest way to do it. So there's some cleanup that we need to do in order to make the mesh ready for further modeling. So if you select this mesh and press 3, you will see Maya in, let's say, a smooth mode. Because this is a high poly mesh count mesh, it will always ask us if we are sure whether we want to do this. You can say yes. It should be, your PC should be able to handle it. The way that you can see that something is wrong is you can see that there are these lines that are not exactly soft. That's because the edge is detached within a closed mesh. And the only way to clean this up is to either use mesh cleanup, which technically sometimes destroys this pattern, which we don't want. But luckily, there's a very simple sort of hacky way in which you can do it. And that's by exporting this mesh as an OBJ. So you will select this object, go to File, and then Export Selection. You will choose a little dialog box next to it. And then Export Selection as an OBJ. You can choose the file here and export it anywhere on your computer. I already have a previous version exported here, so I'll just overwrite it by exporting it over. We can now kill this mesh and then go to File, Import, and just re-import the same one that we just exported. It's quite funny, but because OBJs actually carry a lot less information within them than Maya files, obviously, because they're only used for storing geometry and basic material files, it actually kind of cleans the mesh for you. So we are going to select it again, press space, and sort of reapply our display settings, which highlights the naked edge. So go to Display, Polygons, Custom Polygon Display, then apply it again. And if you go to 3 now, you will see that those areas that were kind of kinky, they sort of bonded up into one object. But the resulting mesh that we have is quite a clean one. So I think this one is more workable. So this is basically one of the meshes that we'll be using as a base, and we can call this one Diagrid. and we can now hide it. We can control and duplicate our base again, because we want to create a different version of this mesh. And a nice, useful command that has appeared in latest versions of Maya is a command that enables you to retopologize this mesh. Whenever dealing with like modeling, obviously high poly meshes are kind of difficult to control. So one way to do it is either to use quad draw to kind of redraw this mesh in an easier fashion, like we were doing in the first version of Hyperskins. But another way is also to automate the process in some way by just selecting the mesh, going to mesh, and then choosing retopologize. This will trigger basically a little process that tries to compress the amount of faces that are used to describe this object at the expense of detail, obviously, but gives you a mesh that has fewer faces, meaning that it's a bit more easy to clean up and perhaps to model further on. One way to retain symmetry and kind of make sure that the output object is as similar shape-wise to the original one is to navigate to the polyretopo node, which you will find in the attribute editor. So within the attribute editor, if you just find polyretopo, either by scrolling until you hit something that says retopologize or navigating directly to it, you can see that you can choose the target face count as well as certain other options, but the one that we're interested in is preserve hard edges. So if we preserve hard edges, it will recalculate and try to symmetrize the mesh a little bit more. So we see that a lot of the details actually being retained while the face poly count is being kept to a minimum. So once we're happy with this, and I think this is looking okay in terms of face count, we can go to edit, delete all by type, and delete all of history because we want all of the nodes to be flattened. So what we're going to do with this one is create a hex grid or a hex mesh as a base. In order to do that, we need to go to face mode by right-clicking, holding down, and navigating to face, and then releasing. Double-click any of the faces in order to select the entire shell, and then with space, again go to edit mesh, and then triangulate. A triangulated mesh is a good base for a hex mesh because once you chamfer each vertex, what you'll eventually end up with is like an n-gon mesh. So it will have many edges per face. And to do that, we need to go to vertex mode, select all of the vertices, and then using Shift and right-click, we can choose chamfer vertex. Once the vertices are chamfered, it will give us an option in polychamfer to kind of change the extent of the vertex chamfer. You should go for 0.33 because that kind of gives every edge the same amount of chance of like expanding. So you get something that's pretty close to like as uniform as it can be. Because these objects are still kind of reminiscent of the original mesh, so that the distribution makes it look sort of wonky. The way to clean that up is to go to vertex mode, select all of the vertices, press space, and then in edit mesh, average the vertices. You can repeat this action maybe once or twice by pressing G, which just repeats the previous action within Maya, until all of the n-gons kind of start equalizing a little bit more. This, however, creates a mesh which looks kind of funky. It's not really, no longer really narrowly describing the original shape of the body. And in order for us to be able to mount it later on after other operations have been performed on it, it would be much easier to actually try to make it kind of look a little bit more like the original mesh. So that we don't do this sort of step by step or in like a very long way, we have certain modifiers and deformers that can help us do that. So this mesh, which I'm going to call n-gon, we can clip to the original base mesh. So by pressing Control and left click and choosing the base mesh from the outliner, we can have the n-gon selected first and the base mesh second. and then navigating to our modeling tab. The modeling tab option is in the upper left corner, and then in the form, there should be something called shrink wrap. So the first option of the shrink wrap is kind of nonsense. It won't help you out much, but it can be reset. So you can select the n-gon mesh that we just created. And then in the attribute editor, start scrolling while hovering above these little title cards until you find something called shrink wrap. So right now the projection is towards inner object. You can change that projection method to closest. So you can see now that while the clipping is not perfect, like there's certain areas that are kind of wonky because of how the mesh is made, and fingers usually tend to look a little bit worse off. The general body or the torso actually is clipping quite nicely and finely to the original mesh, which makes it easier for us to mount it later back on the existing body mesh. In order to tweak it a little bit further, I usually offset the mesh and inflate the target a little bit so that we know that it's kind of hovering above it rather than like intersecting with it. And in order to kind of introduce a little bit more control, you can also turn on shape preservation controls, which will tweak it a little bit further so that it kind of conforms a little bit better in certain areas to the original mesh. But essentially what we're aiming for is kind of like a better description of what our original mesh was, which this kind of does pretty well. So once we're happy with this, we can delete the history once again by going to delete by type and deleting history. You can also do that by pressing Alt, Shift, and D. And we have a nice n-gon mesh to work with further on. So have a diagram and an n-gon mesh. And we can work on them separately, but they will adhere to the same, let's say, skeleton or the same body base, which makes it easy to like sort of mix and match in a sense. One more base mesh that I will create before we move on. We can now hide this one by pressing Ctrl-H. We can navigate to the base mesh again, and then press Ctrl-D to create yet another base mesh. Shift-D to unhide it. Sorry, not Shift-D, Shift-H. Shift-D creates an instance. So Shift-H will unhide it again. And with this one, I think we could again use the retopologize node. So select the mesh again, go to mesh and go to retopologize. We will kind of repeat the logic from before and make sure that preserve hard edges is on. And then delete history. I'm not going to select all of the edges, but in order to kind of create more interest into how this pattern will be generated, I'm going to remove some of the edges manually. So by pressing Control, you can remove stuff from a selection. So I'm going to like try to remove edges in a way that kind of feels like a staggered pattern of sorts. So kind of try to grab the edges that are like maybe in the, let's say, horizontal direction, and try to select them in a way that kind of is staggered. Don't have them sitting one next to another. Just keep trying to select ones that are one subdivision away from each other, and like heading almost like kind of like, let's say, brickwork of some sort. We don't need to do it for the entire mesh. We just need to create enough interest so that the mesh doesn't look like a simple quad mesh. You can do it in the back as well. Just going to do it in a couple of places. Here, let's do some on the head as well. Some on the sides. It doesn't need to be symmetrical. You can just do it like very freestyle. This is, I think, enough, to be honest. After we have the selection, press space, go to create, and then create a set. And then leave the object mode. And then when you select this object, you can go to poly modeling and subdivide it once by using the smooth option. So it should be in polymodeling smooth. You will subdivide the mesh in once, meaning that every face that you originally had will become 4 new faces. That is closer to like the smooth version of your subdivision. And we are now going to use our set by selecting the set, right-clicking, and selecting set members to extract these edges, which actually give us a little pattern that we've created underneath. So by staggering, we kind of avoid the full alignment of these subdivisions, which I think creates more interest in the pattern itself. So if you step into edge mode, press space, go to edit mesh, and detach. And then you press 3 in order to look at the smoother version of the mesh. You can actually see that these edges are now detaching and creating openings. So in order to visualize these edges a little bit better, we're going to select the object. And in your attribute editor, your shape node should open up by default. And usually, if you just scroll down, there should be something that says open subdiv controls, and the vertex boundary by default usually sits at sharp edges and corners. If you choose this drop-down menu and use sharp edges instead, even the vertices that are at the edge of a shattered polygon will also try to be, in a sense, smoothed out, so you can see your subdivision a little bit better. So basically, you can also tell that if we could continue to kind of choose certain edges and remove them from the selection, perhaps the pattern would be even more exciting. But what we actually want is just a little bit more excitement on the torso. The rest we can discard. So this one, I can also see that there's some issues on the mesh. Sometimes when you detach, you will have these singularities where like there's one welded vertex in between two faces, which actually doesn't geometrically work. It will always appear as this like a kind of spiky area. You can rather easily fix this by selecting the object, pressing space, going to mesh, and then mesh cleanup. Mesh cleanup generally will fix this kind of issue quite well without disturbing the rest of your mesh or the pattern that you've created. So this one, maybe we can call patch. We can hide that one. And let's go back to our diagrid now by pressing Shift H to unhide it. And let's perform some operations on it. So because I'm going to use this diagrid to do a little bit simulation on top in order to kind of create inflated pockets within the mesh, I think we're going to have to rework the topology a little bit, because sometimes there's a little bit of a weird situation when inflating meshes that are made from triangles. It's better that they're quads, but instead of remodeling this to be a quad, we can just retopologize it the same way we did when we were creating the other base meshes. So selecting the mesh, going to mesh, retopologize, and just give it a little bit of time, because with higher polycount meshes, it will be a little bit more laborious in terms of your computer trying to fight for every piece of RAM that it owns in order to recalculate the mesh. So it just takes maybe a few minutes. Basically, what we want to achieve is to avoid the triangular tessellations, and then make sure that we actually create a quad output, which Maya tends to work better with when we simulate on top and add encloth effects on it. So you can see that like it's doing a decent job, but a lot of it is quite jagged. It's looking a little bit too, let's say, it changed a little bit too much. So we can increase our target face count, which now, because the objective is not to reduce face count, is just to turn it into a quad. I think we can easily up this to like 7,000 and then allow the calculation to run again, so that we get like a finer result that's actually a bit more concordant with what we have within the mesh. Oops, that might have been too much. Let's try a little bit less. Sometimes it just cancels the operation if it's like too costly, so it will revert back to the original mesh that you have. I think 6,000 should be okay. Let's see. Let's give it another minute. Yeah, that's not a bad output. Right now, because I'm kind of happy with the output as it is, I'm just going to make sure that we kill our history so that this node doesn't update again and create more issues when we start working with this mesh. The reason it's green is because sometimes the link to the shading group breaks when you retopologize a mesh or do a certain operation on it. So it becomes green. It loses the material. Green basically means material missing in Maya. In order to fix that, you just need to right-click and hold, go to assign existing material, and we can just assign a Lambert that is already there. That's looking better. I'm also going to change the display mode of this mesh by selecting it, going to the attribute editor in diagrid shape, and then in vertex boundary, we change to sharp edges again, just so that these situations when we have two vertices meeting in one spot don't produce like those little spikes, which don't look that great. So I'm quite happy with how this diagrid looks, but I'm going to create a duplicate of it just in case. And I'm going to hide this other one. Because we're going to be working now with cloth, which is computationally a bit heavier. I think we can afford to lose certain areas. I will remove the head tessellations and the ones that are on the fingers and the hands, because those won't simulate that great probably anyway. So we can step into face mode, just randomly select what looks like most of the head. And then whatever is connected to this, to the rest of it, we can control, right click, open up this rollout menu. Whoops, I was a bit too excited. And go to shell. Shell will basically attach to everything, or like expand your selection method to everything that is connected to the faces that you already kind of selected prior. I'm going to remove this because I kind of want to do this in sections anyway. In order to remove this section, I will press space, go to edit mesh, and then go to extract. If you step into object mode now, these will be separate meshes to the rest of it. I'm going to treat this as one section of the suit. So I will select all of them together, and then just remove the rest of the torso or rest of the body from the selection and make sure that this is combined, in fact. So while we're in object mode and selecting all of the objects that we want to combine, we press space, go to mesh, and then go to combine. So this is now one object, which is good. I'm going to sort of perform a few more separations. And again, I think the method can be quite random in a sense. So we go to face, kind of try to just drag and select over the torso, let's say. Then go to control, right click, and then go to shell. So you can take out a bigger chunk. Another good way of doing this, which will actually kind of allow you to visualize things before you actually select them, because I kind of feel like this is a bit too much, would be to actually use selection constraints actively. So in order to access selection constraints is to press Control and right click again. Well, you can select any of the faces, doesn't matter. And then with Control and right click, there should be something called selection constraints. So if you open that, a dialog box will open, which allows you to constrain the way in which you select basically either vertices, edges, or faces, doesn't really matter. So what I'm going to do is affect the propagation. So the propagation right now is off. If you switch it to shell, you will see that when you hover above any face, what you're actually extracting is the entirety of the shell of that face, meaning everything else that is connected to it but not disjointed. So if I use Shift and left click to add to my selection, I can just keep adding until I'm kind of happy with my full selection. And I think like this might be good to get the shoulders in, a little bit of the pectoral area, maybe some from the back. Yeah, this is not bad. So now I'm going to extract that as well by pressing space and then going to edit mesh and extract. Again, if you switch back to object mode directly and maybe just remove the rest of the selection by pressing Control and then left click, I can combine this again. We have 2 sections for now that we can work on. In order for this to work properly, don't close it without always closing and resetting. If you don't reset, it just kind of keeps applying the same mask and you keep using only the selection constraint of shell or whatever it is that you've set up. So it can be quite annoying if you forget. So make sure you always close and reset. These 2 sections, I'm going to, again, change the custom polygon display as we did before, just so that I can have an inkling of how this actually looks. And I'm going to change the vertex boundary from sharp edges and corners to sharp edges, so we have a smoother version of it. For now, we'll leave this alone. Maybe we'll add them in later, but let's just try to work with what we have right here. So the reason I moved it into segments is because while we can do the whole thing at once, it usually ends up having simulation times that are quite long and kind of boring to sit through all that. So I removed it in sections so that we can actually see what we can do with a smaller section, which will simulate a bit more in a bit more faster manner. So the simulation that we need to perform on top of this will need definitely more subdivisions. Situations in which you have just one face just don't work. Like you need at least, 4 would be the bare minimum for this one, but we can increase the number of subdivisions by going to our smooth option. But instead of just clicking it, double click it to open the options for it. And make sure that in your vertex boundary, you choose sharp edges and, sorry, the other way around. This usually by default is on sharp edges and corners. If you just also include sharp edges, you will see that the way that the mesh smooths also respects the smoothing that we set before, which means that not only does the interior edges smooth, but also the exterior edges and vertices where only 2 edges meet, as opposed to 3, will also be smoothed so that you actually have like a nicer, finer result. I think we can do it once more, and this is probably enough to get a decent output from it. So now that we have that ready, we can go to edit and delete all by type history because we don't want like any nodes to be affecting the simulation. And by selecting this object and going to the upper left corner, which is now describing modeling, you need to switch from the modeling tab into your FX tab. The FX tab in Maya kind of handles a completely separate, let's say, completely separate subset of commands to modeling. And it pertains to simulation of fabrics, fluids, particles, anything that's a dynamic object that follows, let's say, the laws of physics in the real world. That's what you can find in the FX tab. So while selecting this surface, which we now have, you can go to Encloth, which is on the upper ribbon. And from the drop-down menu, choose Create Encloth. Once you create Encloth, this object is no longer editable in the same sense that other meshes within the scene are editable. Like you can no longer perform modeling operations on it. It's frozen in time because it will now only be affected by the simulation. So in order for the simulation to run, we actually need to use our timeline. which is in the lower portion of the screen. This basically shows you the frames. So whether you're animating or simulating, as the frames develop over time, you should be able to see the changes within your screen. So by default, if I just start playing it, you'll see that the whole thing just kind of drops, because obviously the gravity is driving it down, and while it's being driven down, it also kind of, you can see that it deforms because it is a cloth. It's trying to act as if it's a fabric. So if I stop that and then rewind back, it will pop back into the original position. But now we can use constraints on top of it in order to control the way in which it deforms. So you can select this object, go to edge mode, and perhaps we want like only the edges that are located all around the naked edges of the object. So basically, we don't want anything that's inside, and we want to constrain only the stuff that's on the border. So in order to do that, we can select all of them together, go to select, convert selection, and go to edge perimeter. By doing the edge perimeter, you're only getting the naked edges. And what we need to do in order to freeze them in time, so to speak, or in space, we need to go to end constraint, which is right next to end cloth. You have end here as well. So end constraint is here, and then you need to transform a constraint. By transforming a constraint, if you go back to the beginning, sometimes it will not visualize if you're somewhere later in the timeline. So make sure that you rewind by pressing the rewind button to go to the start of the playback range. By adding this constraint, it kind of freezes the entire subset of these components in space. And when you try to play this again, they will be fixed. Whatever's in between, though, will still be allowed to move freely. So if we stop the simulation and then rewind to the beginning, we also want to push this out because we want it to sort of inflate in a way. So if you check out your outliner, you will see that in addition to your geometric shapes, which are all these meshes and whatnot that we've created so far, we also have something new that's called an end cloth. It's kind of signified with this little shirt. It's because it's a dynamic object or solver that is now attached to your a mesh, which is this one here, one of the copies that we created, and a dynamic constraint control object, which is the one that clips all the naked edges to the edge of the mesh. So if you choose the end cloth in your attribute editor, you will actually see quite a lot of options that you have in order to control this object. I'm going to like collapse all of them so that you can see where I'm going with this. So in the attribute editor, the first thing that we're going to check are collisions. Collisions relate to the ability of this object to recognize other objects that are also dynamic and collide with them properly, which you also see in nature, right? Like if you kind of touch a fabric, it curls or something. So in collisions, the options for the collision are collide and self-collide. Right now, because there's nothing else in the scene that's dynamic, we don't really need collide, but we can keep it on. It will just be computationally irrelevant. Self-collision will mean that this fabric understands that it can curl onto itself if it's pressed or something. So it basically collides with itself. And you will also see the options that show you the thickness and the self-collide width scale. In order to visualize what now computationally is happening when this collides, you need to choose your solver display and switch it to self-collision thickness. And basically the way that this will be calculated is like these spheres will essentially collide with one another. And as they move the vertices of the mesh, and the mesh deforms to describe the movement or the motion of those vertices. This is the least computationally costly and also conversely speaking, the least accurate way to compute the formations in fabric. So we will switch the self-collision flag from a vertex to a vertex face. Vertex face uses more of the, obviously, the surface to solve collisions, which means it's, let's say, it's tougher for your on your machine, but the result is nicer. Right now, the self collision width is also massive. We don't really need it to be this big, so I'm going to make sure that this is 1, and the thickness could even be 0.05. Like it really doesn't need to be too thick in order to get what we want. And by making it thinner, you actually save some computational time because not as many obviously objects will collide with one another. So within solver display, you can turn it off now. And then you can move on to dynamic properties. In dynamic properties, you'll see the properties that any fabric would have. We're only interested right now in stretch resistance, which by default is 20. You can lower that a little bit because we want the fabric to be more sensitive to deformation, to let's say 10. And the compression resistance I find for better output of, or like less deformation within the kinks of the edges of the mesh itself, is better for this to be a bit larger. Feel free to make it 100, doesn't matter. So now we need some kind of an input that forces change onto this fabric. And the easiest one to use is actually pressure. So if you collapse these sub menus, you will find that one says actually pressure. If you go there, make sure that the seal holes is unchecked because it sometimes creates confusion. If the seal holes is unchecked, the expansion of your object always goes in the direction of the normal of each face that that is actually creating the mesh itself. So the pressure here, let's just put it at 1 at first. So your meshes will try to like pop out a little bit. So you can see they're deforming. In order to increase the deformation, obviously the way is to increase the pressure or decrease the ability of this fabric to resist stretch. So either increase the pressure or in dynamic properties, make sure that the stretch resistance is even lower. You'll see that, as you kind of are trying to find the best settings for this, this actually takes quite a lot of tweaking. And if you kind of overestimate the ability of this object to, let's say, handle itself, it will actually explode in a sense. So for example, if I wanted to show you how that happens, is if I increase the pressure too much, it'll probably inflate beyond its ability and the kind of simulation fails, and it kind of creates this like unreasonably large deformation in your object. A good way to control that, especially where pressure is concerned, is to actually add it in a very controlled manner, meaning that you don't just start with a pressure that's already high. You start at 0, which is going to be at the beginning of your timeline. And then in pressure, you right click above. So basically every numerical value in Maya is keyable. It means that its value can change over time depending on the keys that you set. So the keys that we're going to set for this is that at the beginning of the timeline, it's 0. So if we right click and set key, it will be zeroed out. But then let's say at frame, I'll say 30, it can become 5. The pressure can become 5. And then before we do anything else, we need to confirm the key by right clicking again and setting the key. So you will see that once the key is set, the field turns red. If the field is pink, it means that there's a different key somewhere else in the timeline, but you're only reading the interpolated value at that point. In order for you to fix that value, you need to key it, or rather go to set key and then it goes to red. So now if you play, it takes a little bit of a while for it to inflate, but then it makes it a bit easier for you to catch it before it kind of goes beyond its abilities and kind of explodes. So let's say we're kind of happy with one of these results. I'm going to freeze it, meaning that if you use Control-D to duplicate this mesh, it'll create a duplicate that is no longer linked to the dynamic object. And if you just move it to the side, it will always stay the way it is, even if you rewind, which makes it very easy for you to kind of keep track of tests. Okay, so let me see. There's a question. Once you regulate the pressure, it varies once you start, for example, adding other layers to the one you've applied pressure, or once adjusted it to a fixed value. I'm not fully sure that I understand, but if the question is whether you can regulate different pressure at different points within the mesh, I would say that, yeah, that is definitely an option. And also it will respond to, if you mean other layers as in other meshes that are also dynamic, it will respond to them as well. So one way to regulate these patches, let's say, to regulate these patches pressure-wise, meaning that like not all of them have the same pressure applied, is to actually force a component constraint on top of them. So we can see that, for example, these guys, they inflate quite a lot, while the rest is not allowed to inflate so much because these are kind of expanding so much already. We can kind of control how much that expands. And the reason why they expand more is because they have more faces available to them between two sides of the constraint, you know, like this one has a lot fewer than this patch. But the way to kind of keep it in place a little bit, but still allow it to deform, is to select the object, go to face mode. Yes, it is interactive. So you would select this entire patch, go to end constraint, and then apply a component constraint on top of it. You'll actually apply a component across all of the faces of this sub mesh. And you can see that if you try to simulate it again, it has a little bit more trouble expanding, which allows other elements to expand more. So you basically want to tweak this a little bit so it's not so constrained that it cannot expand at all, whereas the other elements are expanding too much. So by default, when you add the component constraint or dynamic constraint, it will also show up in your outliner, and you can control the strength that it is allowed to exert on top of the object. So let's just hack this down to 10 instead of 20 and see how the deformation works then. That's not bad. You can change it live as well. So you can see how it kind of pushes out a little bit more. Because this is like really time-based, you kind of want to give yourself the opportunity to tweak things on the fly rather than trying to do them like in one go. Let's say that this is also like a successful tryout. So I can Control-D to save this as well and just move it to the side. There's a little bit more control in how this kind of expanded here versus here, let's say. Thank you. Okay, so for example, like I said, the collision flags of this mesh are also different. Right now, the ones I'm using is vertex face, and it's quite an accurate one. You can go up to full surface as well, but depending on the size of the mesh, it can be quite costly. So just as a reminder, you can also choose vertex, and if you play that, you will see that like it kind of it's faster, and for this particular one is not showing up so many issues, but because we're using because these are our collision flags, the meshes that expand too much will eventually start to intersect, which will not be a problem here. So just as like a small reminder, while you're working and still trying to figure out whether you're happy with the inflation, it's good to use vertex because it makes it fast. But once you're done, it's usually better to switch to something that's a little bit slower, but produces a better result. So either a vertex face or full surface will suffice. And the result will change like slightly depending on what you actually have. Sometimes it's more relevant than other times. So if I go back to the beginning, I'm going to take this cloth, the one that we worked on so far. If you select it from your outliner, you can choose whether or not you want it to be active. So right now, it in its attribute editor, like the little enable is ticked, which means that it's working or it's active. What I'm going to do is I'm going to untick it because I actually want to make it static. So I'm not basically allowing it to simulate because I also want to perform a little bit of simulation on top of whatever we have as the head. So for the head, I'm going to duplicate it just because I want to save one option of it where it's low poly, which really I should have done for these as well. It's always good to to save like lower poly versions because you never know when you might need them. And I'm going to subdivide this a little bit. For this one, I actually don't think I'll subdivide it as much. Maybe even this is enough. Yeah, let's not make it too heavy. And I'm going to go to edit, delete by type, and delete history. Be careful when deleting history if you have dynamic object in the scene. Sometimes if you delete history of the entire scene, it will break the links between the dynamic object and the mesh it affects, and you might have a little bit of a mess on your hands. So if you're only modeling, then it's fine, but if you're also doing other things in the scene, it's better not to be honest. So I'm going to do the same thing that I did before. Going to FX, turning this into an encloth. And if I play, only the head will simulate, the rest will not, because it's been disabled. And this time what I'm going to do is I'll turn off the gravity first. If when you rewind, sometimes this kind of really weird patches of dark appear on your mesh. Usually what fixes it if you just select the mesh and hit once and it just kind of goes away. But what I'm going to do right now, I'm going to kill the gravity because I actually don't want the mesh to be like sagging down. I just want to affect it like in its position with a force rather than with gravity as a separate force. So you can go to your nucleus. A nucleus is an object that is always created when you have a dynamic object in the scene. It's a solver. So basically anything that happens within your environment that's related to physics is pulled through the nucleus. So it kind of unifies all of the dynamic objects into one solver. So if you select the nucleus from your outliner and go to your attribute editor, you will see that the gravity right now is on. It's roughly the same as the gravity that we have in nature, which is 9.8. If you just pull that to 0, gravity will be a moot point. It will not be affected. It will be like as if it's in 0G. So if you play again, the object actually won't move because there's no forces acting on it. I think what sometimes can be quite interesting is to like take this object and then apply pressure on it without any constraints. I'll make sure that seal holes is off, because then objects just sort of fly off like this. The reason that can sometimes create interesting results is because you can also take every, let's say, frame of this deformation or over this explosion and turn it into an object, and then create like a sort of like a slow motion effect of like all the states in which this was as it was expanding. So if we rewind back and then select the object and hit 1 to remove the dark patches, we need to cache this simulation in order to be able to access each frame of it in like a very easy way. What you will find with simulation is that it's not like animation where you already kind of know what is coming next because you've animated it that way. If I just scroll to any of the positions within the timeline, usually what happens, you will have this little warning and it will say nucleus evaluation skipped, frame changes too large, which basically means you're not giving Maya a chance to calculate the deformation or all the functions of deformation between two frames, which makes it incapable of kind of deforming the object. So every time you kind of play, you have to like wait in time until it reaches a point in which you're kind of happy with what's going on. So in order to avoid that, there's something called caching. We're only going to cache maybe like 20 frames. I don't think we need more. And I'm going to limit my timeline to 20 frames. These two numbers will do that for us. If I type in not 220 in the first box, it will actually just limit the timeline between 1 and 20. And what I want to do is take this object that is now a cloth, and in our FX tab in the menu on top, there will be something called N cache, and then you can create new cache and you can choose an object. I will open the option box just to kind of describe it. It will give you a couple of options for your cache file. I usually say that the file in file distribution that it should just be one file. Otherwise, it creates one file per each frame, which can be a bit annoying. And you can also give it a range of frames that you want it to actually cache. You can either use time slider, because in this case, my time slider aligns with the number of frames that I want, which is 1 to 20, or you can, input manually, like start and end 1 to 20. I'll use the time slider this time around. And if I apply, it will play. It will save out all of these informations, but then it will make it, like you will actually be able to like scroll in and out, and see each frame separately. The reason why this is great is because it kind of allows you to kind of plan out other things within your scene as this is developing. However, this object is no longer a dynamic object. Like other objects will not affect it. You're basically just reading the information from your machine, which is now being calculated and then written into a file somewhere in your default Maya folder, and which is incidentally why it allows you to like scroll through all of them and kind of open up each frame separately. In order to kind of save out these frames and turn them into geometry, obviously you could just like go one by one and copy them, but there's also a quicker way to do it by using animation snapshot. So by using animation snapshot, you can just select the object itself. Then from the FX tab, you will actually need to navigate to animation. Your drop-down menus on top will change. And then in visualize, you can create animation snapshot, choose the little option box. And then right now I have timing from 1 to 12, which to be honest, probably enough, but let's put 1 to 20. It will ask you for an increment. Increment actually relates to the number of frames that you want visualized. So if the increment is 1, it means every frame is visualized. If the increment is 2, it's every other frame, and so on and so forth. So if you apply that, it actually gives you like this kind of, how to call it, like a history of all the positions within within a timeline of this, of the formation of this cloth. And it ends up giving you this kind of like quite an interesting shape because you have everything copied out. The way it's copied out is that it creates this like snapshot group. And within the snapshot group, in order, you have all the frames created as objects. If you were to delete the cache or delete the original file, the snapshot group would, let's say, update automatically, which means it would just disappear. So in order to make it like a static object, you can just duplicate it. So select the group and press Ctrl D to duplicate. So this one's dynamic, the original one, but the second one is not. So I can just delete the original one because we only want this as like an object that is working out for us. So I'm going to move this to the side just because I kind of wanted to maybe perform other operations. We can align it with one of these. So we have like a mix of two things that we've done so far. And sometimes I feel like it really pays to sort of maybe freeze certain parts of the animation in order to create a little bit more of legibility of the fact that this is a head and not just a mishmash of, a lot of fabric elements are flying every which way. So in order to do that, we can also apply transform constraint into sections of the face that kind of still retain some idea of what the face should be. In order to make this cloth dynamic again, we need to select the cloth, go back to, let me just make sure that this is the one. Yep, it is. So select the cloth, go back to your FX menu, go to end cache, and then delete cache. By deleting the cache, this kind of, again, is subject to deformation, basically. And you need to, keep track of, let's say, what's happening. So what I want to basically do is maybe take segments of this and just fix them in space. I think anything that's like really close to the face should actually remain fixed. So just so we're not doing it like very slowly, I'm going to freestyle it a little bit. So I'll select the object, press Ctrl+1 to isolate so everything else is occluded in the scene. I'll turn it to the side. go to face mode, and just grab whatever looks like the face. I think like certain segments I can let go of in a sense, or rather to maybe to create a little bit of a better selection, I will step into my view and just select from like a side view because I want this to be as symmetrical as possible. So to do that, you press space and then release, and it will open up the view. So you just need to find the one that's a side view, which for me is the lower right corner. And if you hover above it and then just press space again, it will make it larger. So this is an orthographic view, so there's no rotation. And if I press Ctrl+1 again, I will isolate this object. So we go to face mode, and then I just want to drag select as many of these as I can. Press space again to go into view, press space again while hovering over perspective to go into perspective. And this looks symmetrical, right? So I can use Control in order to remove subsections by double clicking. You just kind of remove the entire shell. And for these, I actually want it to be partially selected. So some of the shell can still move. There's no need for it not to, but the rest can stay in place. I'm going to remove this just to stagger it a little bit. So I don't, maybe that one was good. You can actually also undo selections in Maya. So if you go Control-Z, you will also take selections into account while stepping back in time, which I think is really great. I'm going to maybe remove some of these. Let's remove everything on top by pressing Control and then dragging, because I still want some of it to be mobile. Maybe we can even afford to take this out. Yeah, something like that. So I'm going to go to unconstraint, transform this constraint, go back to the beginning. And I think like, even though obviously it's not perfect, it kind of leaves at least a trace of the face within the simulation, which kind of creates a little bit of a better outcome, I would say. Let's make a cache of this as well. So the same way they did it before, go to end cache, create new cache, and now you can just save the settings from before. Because we already created a cache before, it will create a cache warning. It essentially is asking you, are you sure you want to overwrite an existing cache? Maybe you're using it from something else, but in this case, we're not. So we can just replace existing and just let it do its thing. And then perform an animation snapshot on this again. So we'll press Ctrl+1 in order to get out of this mode. That is isolation mode. And then by switching to animation, going to visualize, create animation snapshot. We can use the same setting as before. And it kind of does leave this trace of a face somewhere inside of all this jumble. So it looks a little bit more like a person wearing a mask rather than just like a cluster of things all bundled up together. So I'm just going to move that over. I'm going to delete the snapshot group, revert back, select our object, or our like dynamic object that is. Yeah, that's not looking bad at all, actually. This, I'm just going to, by the way, like when you have a group and you just select one object within it, it tends to only select that object and not the rest of the group. The easiest way to, go get around this is either to select the group from the highlight of the group in the outliner, or just press arrow up and it will select everything that's within the group. I'm only doing this because I actually want to move it to the side a little bit, because my gizmo is at the base of the feet, which makes sense because if you want to scale this person, you want to scale them at the base. It's kind of out of view. So in order to move the gizmo up, I could press D and just drag it by its vertical axis. And then if I press D again, it will lock the gizmo and I can center it into place. The reason for me it's centering like this well, and you don't actually need to think about much, is because I have a relative step snap on, which you can turn on as well if it makes it easier for you. So if you go to the upper right corner of your screen in tool settings, while this is in translation mode, you can make sure that your step snap is on to relative, and you have like a 1 unit of step snapping. So that actually creates like a way for you to like lock things into place quite easily. You can also just inherit the transformations of each object by selecting the object, selecting the target object, pressing space, going to modify, and matching transformations, in this case, the translation. So the translation for this one, because it's locked down, it will move it into the right place, but not in the right position because the gizmos of these two elements are not aligned. In order to fix that, you can align the gizmos as well. You can select the object, select the target object, go to modify, match transformations, and match pivots. If the pivots are matched, both of them should have the same pivot. So let's move on with building up the, let's say this suit. You can also see that there's certain like areas that seem black. This is just Maya visualizing your back face. So by default, it's black. It looks like it has no material on it. Sometimes I find it nicer to actually not see that. So in lighting, you can choose two-sided lighting, which actually shades the backside as well. I'm going to take these objects here by selecting one within the group, pressing arrow up key to select the rest, and then shift and left clicking to add to selection, and just change the display profile. Yeah, that visualizes a little bit better. We can see what we're doing. So I also want a section of this to kind of relate to, let's say, almost like the shoes, I suppose. So I'm going to get like this segment here and create, let's say, some kind of wearable shoes for the suit. So we can select the object, go to face mode, just kind of randomly select this by dragging and selecting, and then with control and right click and changing to a shell, you actually get the boots. Maybe I'll add a little bit more. So if you want to add to a selection while also hovering above something that was already selected, usually what happens in Maya is like it just inverts it. Like if you reselect something and kind of removes it from the selection. If you press Control and Shift together, you can always add to the section whether or not it was previously selected or not. And I can use Control and right click to go to shell again. That's pretty good selection for shoes, boots really. And then go to edit mesh and then detach. Whoops, rather than detach, what we actually need to do is extract. So edit mesh, extract, switch to object mode, use Control and left click to remove the rest of the mesh from the selection, mesh combine in order to get a full mesh from this. I press 3 and I change my vertex boundary from sharp edges to corners to sharp edges, and maybe the display just for good measure. Yeah, this looks like a good selection. It just is woefully under subdivided, so we need a little bit more subdivisions in order to create another inflated area of the suit. So let's do FX and cloth, create and cloth, select the object. So I'm just repeating some of the commands that we did before, but just much faster. Select, convert selection to edge perimeter, end constraints, transform constraint. But I've failed to subdivide, unfortunately, so we're going to have to go back. In order to detach something from the dynamic of a cloth, the easiest way to do that is just to delete the cloth and the related dynamic constraint. This will revert back to a regular geometry or regular object. I'm going to select the other cloth and make sure that it's not working, so I'll just disable it. take this new one, subdivide it once, maybe even twice. Let's leave it at once. We don't want it to be too heavy, basically. You can do it even more if you're looking for like a finer result, basically. That's not a bad idea. But I think for the purposes of this model, this is probably enough. So select the object, go to FX, create an encloth. Select the object, go to edge mode, select all the edges and convert the selection to edge perimeter. So all of the commands that we had from before, just we're repeating them again and again. So to end constraint, transform constraint. And let's inflate it. I'm going to remove seal holes, put pressure to 3, let's say, and stretch resistance to 3 as well. That's looking quite funny. You will see that also it kind of, it passes through the base, which creates these like huge donuts where feet should be really. In order to have it collide with the base or like with the ground, we can also use the nucleus to control that. So if we go to our nucleus, we can, in our attribute editor for the nucleus in the ground plane, we can click use plane, which will actually force it to collide with the plane and then create like a flat collision here, which creates this impression that it's actually standing on something rather than just like hovering in space. Let's remove a little bit more of the stretch resistance. What? And then I'm going to also expand the timeline because I can't actually have enough frames here. So from 20, we can go back to 200. Just keep playing this. And maybe even increase the pressure a little bit before it explodes, just slowly dragging it until we get something a bit more deformed. So you will see how, for example, here, because our collision flag is now vertices, it actually really freely intersects with itself, which is not great. So if we change that to, let's say, vertex face, that is less likely to happen because the simulation will be a bit more accurate. It will also be, as you can see, much slower. But if you stop it now in time, you can actually see that they are trying to collide with each other. I believe probably the thickness is also quite extreme, so we might as well make that smaller. 0.5. With simulation, a lot of your work will not actually be modeling, it will be tweaking. That's not bad. We can maybe even increase the pressure a little bit more before it gets too much. There we go. Let's say that's enough. It's not particularly symmetrical, but that's easy to resolve. I will control this to duplicate it, move it to the side. I think this is probably correct. And for example, because they're not really symmetrical, I can tell that they're a bit different. I'm going to take the one on the left. So I'll go to face mode. I'll select all of these. We can go to control and then to shell to delete. I'll take this one. I'll press Control D to create a duplicate that's sitting on top of the other. Press R for scaling. And then if you pull it through, you will actually create a mirror of it. But you can also use J and pull it through, which will snap it. So if you hold down the J key, you can know for sure that this is -1, so it's like a symmetrical object. We can now bind it together by selecting two objects, going to mesh and going to combine. And we have something like this. Since it seems that we're using like this element here to create the body, I might as well use the base. So I'll select the base, press Shift and H to uncover it, create a duplicate of it, then move it over. Then we have something that aligns well. That's good. Then we need to move these. That's not bad. Because we've kind of worked with a mesh that's like completely adheres to the original mesh, sometimes it's a bit too snug. Maybe it could even benefit from a small shadow gap in between. So we can also affect that by selecting the base mesh, going to face mode, double clicking any face to select all of them together. And then with shift and right click, we can navigate to transform component. This will allow us to slide each face within the direction of its own normal. So you can just like maybe pull it in a little bit. That's even too much. In order to control exactly how much this amount is, it's much easier to just like do it like randomly and then check out your attribute editor and see which value changes, which in this case is the last value. So instead of typing, trying to drag it to the correct place, might as well just type in minus 0.1 here and to get a little bit of a shadow gap there. Maybe it's even too much. Let's say minus 0.5. 0.5, not 0. There we go. That's not bad. Go back to object mode. Okay, so we have some parts of the torso. I'm going to take this object again. Let's save. Make sure you save, because usually with simulation, Maya tends to be buggy and it can end up quite easily in like a crash. So I'm going to disable this cloth. Disabling the cloth as I work is mostly due to the fact that I want to be able to add more elements into the scene and not have them interact, but also in doing so, save computational time, because if you kind of try to simulate the entire thing, it will probably take a lot longer to tweak and to wait for it to simulate. With this one, I'm also going to remove the cache file. So just navigate to encache, delete the cache, revert it back, and then when you play, your frame indicator should just be flying, meaning that there is no calculation that is being done. So I will hide the base that I have here, Control H, and I'll also hide the diagrid base. Let's leave that one alone for now. So everything that's related to the diagrid we can hide for the time being. And let's navigate back to one of our other bases that were created. Let's choose the Angon one. I'm going to duplicate it by pressing Control D, just because I want to save the original as well. And then with Shift and H, uncover it and see what we can do with this one. So I think this is a pretty great base mesh to work on to get like a pattern outcome that's different to this one. And in order to do that, I'm going to switch to face mode. And I'm going to press Tab. So if you press Tab and hold it down, your cursor changes to this little crosshairs, or like a little circle. This actually allows you to drag and select. So if you hold down your left key and just kind of paint on, you can just choose which faces you select just by basically painting them on, which sometimes makes selection a lot easier. So you can randomly do it. It's not too exact. And then when you have a lot of them, then you just go to Edit Mesh and you detach. Again, I'm going to switch to the smooth mode by pressing 3. And I'm going to update my custom polygon display in order to actually see the naked edges and see the pattern that we're producing. Also, because these are N-gons, obviously these vertices will not be smooth unless you change to sharp edges, and then you get like a nice concordance mesh where all the edges match, even though they are detached. So in order to kind of increase like the frequency of this pattern, I can go to face mode again, double click the rest of the pattern. That's not what we've just detached. And then go to Control, Shift, and Selection Boundary. And then we can also detach this boundary. Basically, we're trying to like design the pattern a little bit more. So it creates like these areas of excitement where there's like different sections within the pattern itself. And another thing to do in order to speed that up is to use random selection. So you select the object, go to face mode again, select all of the faces, then press Control, right click, selection constraints. So like I was saying before, faces can be kind of, or vertices or edges really, any element within the hierarchy of modeling with Maya can be selected in very different ways. Selection constraints allows you to do that. And a good one to use here is the random, let's say, dispersal of selected faces. The way to do it, like usually when you're using constraint selection constraints, it will ask you what do you want to constrain. So it's either nothing, next selection, current, the next, and all in the next. In this case, because we're applying it to the entire object, I will use all and next. And then it will ask you to sort of activate one of these subcategories in order to create the method by which it's selecting. In random, if you just give a percentage of faces that you want to be selected, so it's like 0 to 100%, you can just click activate and it will just select the same percentage of faces that you asked for here. And then in edit mesh, you can detach again. And you can see like the pattern gets quite intricate and also actually works really well even when they're like singular faces that are being detached. Although you should aim for patches as well, just to avoid uniformity in your pattern. So maybe we can afford a little bit more detachment. So I'm going to just reduce the amount of faces that can be selected. And perhaps even like when you select a fewer number of faces and you close and reset, you can also grow your selection. So again, you create patches rather than just like singular elements. So if you press shift and greater than, so greater than is like on your left shift, there is like that mathematical operator that says that like left hand side is greater than the right hand side. So shift and greater than the key that is like 2 keys off from your right shift will basically kind of grow the selection, and then shift and less than will reduce the selection. We can detach these as well. Detach. Yeah, it's creating quite a nice, say, a nice pattern. Okay, so with what we have here, we have like an n-gon mesh. N-gons work they're very notoriously bad to work with in Maya because this entire mesh is n-gons and it's not like super high poly just yet. I mean, it is like at least mid-range. We can subdivide it once and each face will be interpreted into a quad, which works really well for modeling. So I'm going to duplicate this for now and go to isolation mode by pressing Ctrl+1. And then we can immediately press smooth, which will essentially add like this second layer of smoothing, and everything will become a quad. It will also leave like these spaces in between, which I actually want to try and avoid because I wanted to adhere a little bit more to the original subdivision. So in order to do that, we can go to smooth back again, but instead of clicking it once, click it twice to open up the options for it. And maybe use sharp edges and corners, not just sharp edges, so that it kind of creates something that when you press 3, and you can press yes, it's a bit heavier, but not too bad. It kind of still tries to sort of describe the way that it looked as an n-gon rather than like almost like a circle, let's say. I will do it once again though, because what I don't quite like is that there is a little bit of an overlap. So in smooth options, if you double click, you go to edit, you can reset settings, then apply. So we actually want to just see which profile fits it best to avoid this. There we go. So there's many different ways to subdivide. Obviously, some work better than others. If you go to your reset settings, they should be kind of like this. It should be exponential with open subdiv Catmull-Clark. But if you switch that to Maya Catmull-Clark, it will just add the subdivisions, but it will leave the edges intact because I actually want this to kind of align and not like intersect and create issues. So if I leave it like this, then we kind of still have some inkling of the fact that this was an n-gon. It's not like fully a circle, which I think looks quite nice. So this is what I was aiming for. With higher poly meshes, when you go to the mode 3, it can get quite heavy because obviously on top of whatever your base mid-range mesh is, you have a lot of other subdivisions being added. You can use your page up and page down to control this. So page up and page down keys are just above your arrow keys on your keyboard. If you press page up once, it adds one layer of subdivision in 3 mode, twice 2, and and so on and so forth. But for higher poly meshes, you really don't need more than once, and it will make it a bit lighter to work with and it works nicer. So basically, either you do it like this, or you select the mesh in the attribute editor. You can just navigate to your smooth mesh controls, and then preview division levels should be 1. You page up and page down affects this the same way that just inputting a value of like a number would affect it as well. Avoid using something too high because it might crash your Maya. So I'm going to like use this to kind of outline almost, let's say, a grid that is kind of like a wireframe version of this. So in order to do that, I will go to face mode, select all the faces, then press shift and right click and go to extrude face. I'm going to try to offset it. Sometimes it has like mixed results by 0.1, but this time actually it works really well. I think we can afford to make it a bit tighter. 0.15, let's say. That's nice. It has a nice amount of thickness and there's no issues anyway. While this is still selected, we want to grow the selection once and delete whatever is the back face, because as you can imagine, when you offset, or rather extrude the face, there's now 2 layers of faces sitting one on top of another, right? So there's the original face, there's the extrusion side faces, which we've offsetted inside, as you can see on these like edging faces. And there's also like the internal face that has been extruded out, which is now selected. If we grow the selection once by pressing shift and greater than, it will look as if it's selected everything, but it actually has not selected the back face. The back face we can select by pressing Control Shift and I, which inverts our selection. And then we just kill the back face. So what we're left with is a central face and a bounding face, like these little boundary faces that we have here. And if you hit 3 now, you will see how that looks. So basically what I'm aiming for is that I want to keep whatever is inside as a separate object and whatever is bounding around it as a separate object as well. Easiest way to do that, again, let me just save before something crashes. Selecting the object, going to face, select all the faces, then Control, right click, selection boundary, and then extract it. So space, edit mesh, extract. It might take a little while because it's quite a lot of faces. That's good. Step right into object mode. And then use Control and left click to remove everything else from the selection and bind this together by using combine. It might take a while for it to combine back again because it's a lot of faces. Just give it a moment. This is conversely why I sometimes like work with sections of like a torso or an arm or a thorax or chest, because you just don't want to be using the entire thing. Sometimes it gets too heavy. Okay, so we have now, this is a separate object. If we press 3, we can still see that it kind of disjoins here, it's like it's 2 faces sitting one next to another. In order to avoid this, or kind of resolve it rather, we can press space, go to edit mesh, and then merge. If we merge and make sure that our distance threshold can even be 0, because we're only caring about the vertices that are sitting one on top of another. If you go back to 3 mode, you will actually see that this has now fused, which works really well. So if we go to object mode, we have like a pretty nice mesh that goes all around the body, creating like this kind of outline of all these faces that we originally had. I think what works really well is to add a little bit of thickness, but instead of adding thickness by extruding this further, what we actually want to do is choose this central edge along the entire mesh and just move that in its own normal or the normals of the associated faces outwards in order to create that little like bit of kind of impression of thickness. In order to select only those edges, we kind of have to be a little bit sneaky about it, because otherwise you would have to like go around selecting loops of these internal edges, which just does not work. It's too much work to do. So the easiest way to do it is go to edges, select all of them together, then press Control, right click, and create a selection boundary. Right now you only have the outside ones, but you actually want what is inside. In order to do that, you need to grow the selection once by pressing Shift and greater than. And then it will also like start selecting everything that's connected to the outside edge. So the only one that's connected is the one that's like the, let's say the sectional edge, or the one that goes like laterally, but the internal one is not connected to it. So now everything is connected except, or selected except the one that we need. So we just invert the selection by pressing Control, Shift, and I, and then we can transform this component. The same way we transform the component of the face, and we can use the blue axis to push it out everywhere. And this adds like this feeling of thickness to it. I'm going to save now by pressing Control S. This I think can further be improved upon like visually by making sure that there's like a crisper edge. And the best way to do that is actually to bevel these edges. When you bevel an edge, you create a face where the edge used to be. So basically it's like chamfering or filleting in a way. So with these edges still selected as they are, I press Shift and right click, and I go to bevel edge. That might take a while because there's quite a few edges. Let's just see if it works out. Sometimes it crashes when the mesh is so huge, which is conversely why I should have done it in sections like I did in the first batch of tests. But let's try it anyway. It might take a while. Just give it a few minutes. Essentially, anywhere where there is an edge, there will be a face created, the edge offsets on either side of it, and then in between creates a face, which basically means that all of these edges will become quads, and junctures where they're joining will become triangles, which interpolate between the quads that are around. This is taking a bit longer. Luckily, I did save, so if it does crash, we can just pick up where we left off, maybe on a smaller segment, just to demonstrate the logic. Let's give it a minute more. Ta-da! I think it has worked, although the fraction makes it quite tiny. So you can see that these faces are ridiculously small. Let's increase the fraction to 1. And I think I'm just going to leave it alone after that, because it is taking up quite a lot of time for it to perform the action anyway. Fraction basically refers to like the amount of offset that your edge is going to have, and refers to the fraction of the rest of the edge. Almost there. Come on. I can really hear my computer struggling as well. The fan is full blast. Okay, that increased it very slightly, but still, that is what we get. So the preview division level is 2. I'll push it down to 1 rather than 2 because it's high poly. as we can see, and then hit 3. And then we can see that we have a little bit of a thickness to it. Maybe 2 is fine. And it gives quite a nice impression to the mesh itself. I've removed the edging on our wireframe by pressing the wireframe on shaded on and off, just to kind of see the object a little bit better. Custom polygon display to display the edges. Okay, so now we have this one, but what happens with whatever is inside? So that's this mesh. So I press Control-1 to leave the isolation mode. And what we want is this mesh, the ones that contains the inside object, and the edging one, so we can just see it. So I think would be interesting to try with this one. Let's say yes. And I'm going to reduce the number of subdivisions. Is what if we could kind of take whatever we have here, and this subdivision actually looks quite nice in the sense that like you have these like radiating lines from the center, and create something where it kind of looks like as if those, like those segments are like peeling away and creating something quite like almost like an opening flower of sorts, let's say. So I will definitely not be using the entire mesh because, as we've seen, is quite heavy. I will Control-D to duplicate it just to have it safe. We can even hide it immediately, to be honest. This is what happens when you don't also delete your history. So we might as well do that right now. We're going to edit, delete all by type. Well, we won't delete all by type, but we will select this group. And then edit, delete by type history. Let's just select everything within the group so we make sure that it goes away. Okay, much of it has actually. I just want to avoid deleting all the history because I don't want to unlink these claws. Although, to be honest, I don't think we'll do anything more with them, so might as well kill the entire history. That's fine, doesn't matter. So I just wanted to like clean up what's happening in this group, and we have our meshes inside. We have copies of them. One we will hide by pressing Control-H. There's no need for us to have both. And I'm going to now select some portions of it because I don't want all of it. I'll go to face mode. That actually selection was not bad at all. It's like the one that we already had from before. Sometimes it saves the selection patterns if you had in the previous selection set. So it's quite useful in other situations where you kind of just want to like continue on working. So it's important to also save them. But in order to just kind of demonstrate what I want to with this, I'm going to go to face mode, Control, right click, and then selection constraints, and then turn the propagation to shell again. So let's just select some of them. We don't have to do a lot. Perhaps even in this is enough, but let's just add a few more patches, but nothing too huge. That's fine. Close and reset. Invert your selection, delete everything else. So we're only going to work on these patches so we don't overdo it. Right now, what we have is quite great in the sense that, like, if we wanted the inner vertex, it would be quite easy, right? We just select the boundary of the vertices and then just get whatever is inside out of the selection. But once we subdivide this, in order to have it simulate a little bit better, this will no longer be possible because there will be many more vertices in between. So what we actually want is to first create a selection of the outer edges. So we go to edge mode, select all the edges, Control and right click, and then go to selection boundary and make sure we save this. So we're going to go to space, create, set, and then this set should be saved. And after we've saved this set, we can actually increase the subdivisions a little bit. So we go to object mode, select the object, increase the subdivisions. Although actually for this one, I may want it to also curve while it's subdividing. So I'm going to double click the smooth, go to edit and reset settings and go to apply. Okay, so this one is curving, but these ones are not curving and I want them to curve as well. So I'll step back by pressing Ctrl Z and make sure sharp edges is also ticked. That's what we want. I'm gonna say this might even be enough, but what the hell? Let's add one more layer and then close. So right now we have the external edges, right? Like these are the ones that we actually want, but we also need to create a little bit of separation inside based on the original subdivisions that we said, like with those radiating lines. The easiest way to get to them is to actually select vertices that have a lot of other edges joining up inside of them. So if I go to vertex mode and I select all of the vertices and then go to selection constraints by using Control and right click and then selection constraints, we can actually go to all the next, go to geometry, and then start selecting vertices based on the number of neighbors that they have. So if you activate it at 2, you will only like select these vertices where you have like, just one vertex at the juncture of 2 edges from the hexagon grid or the n-gon grid. If you increase it a little bit more, that's basically everything else. But we also only want the vertices which have a very high count of edges inside of them. So your max should be like maxed out, just place it at 10, but your minimum should be higher. So you kind of want to keep doing it until the only ones that are left are the ones that are in the very center of the original faces, which is what we have here. So anything more than 5, we want selected. We close and reset this and then convert this selection into an edge selection. So every selection, whether it's vertex, edge, or face, can be converted into its corresponding hierarchical pair. So if we press space in order to get to the full rollout menu and go to select, there's something called convert selection, and you can convert it to an edge. So every edge that is attached to this vertex will be now selected. And coincidentally, these are the exact edges that we want to like separate and create like, almost like the fabric is terrible in that area or like it's been cut. So in order to select like the full length of them, you can go to space again, go to select again, convert selection again, and then to edge loop. This essentially just fully connects between all of these together. Then you can detach it by going to edit mesh and detach. If we go to object mode, what we want to do now is to make sure that we get to our naked edges that we've selected before, because now we have naked edges in the center as well, which we can do by going to edge mode, going to set, the set that we created before, and selecting the set members. Now, because we want to retain this set as a way for us to constrain this part of the mesh, what we actually want to do is make sure that we step right from here into object mode. Do not deselect or reselect anything. Just right click and select, go to object mode, leave it as it is, and in effects change this into an end cloth immediately. Rewind to the beginning, and then go to edge mode again. It should remember the last edge that it created. The reason why we can't access the set again, the sets get destroyed once an object gets converted, but the last selection set within Maya by default remains active. So we can just use our end constraint to transform these, and these will become fixed. This also conversely means that these objects, when inflated, should start coming apart. Exactly. So they kind of open up. Certain parts of them, obviously, because we could have been even a bit more strategic with how we were selecting these, like certain parts do seem a little bit like too detached. So obviously, ideally, these should have been attached as well. We could have avoided the need for this if I selected all of the edges of the original mesh that was, let's say, in its like first level of subdivision. But if you just need to like transform constraint on a couple of these as opposed to so many as before, it's not that bad. I'm just going to do it quickly for a couple. We don't need to do all of them. Press G to repeat the action. I'm just going to constrain a few more. Double clicking and an edge actually selects the entire loop that is associated to that edge, and holding down Shift allows you to add more into the selection set. This one really should be constrained a bit more because it's basically a massive patch. And basically looking for junctures where we have like edges joining into like 3 vertices. And then creating all of those edges as like fixed objects in space. Again. Okay, we don't really need to fix all the other ones. It is fine. So let's just see what it looks like. That's not half bad. These are actually reacting quite well. There's a little bit of a mess happening on here, but that's not too bad. We can just go back. So in order to kind of like visualize it as almost like an opening, you know, bulb of some sort, I'm going to, again, limit myself to 20 frames and then create a cache of this. 20 might even be too generous, to be honest. And then in animation tab, go to visualize, create animation snapshot. And like I said, 20 was a bit too generous. Maybe 12 is even enough, especially if the increment is 1. Then apply and close. Right now, you're not seeing it because we're still in isolation mode. But if I step out of isolation mode, you could actually see them quite well. And new snapshot group creates like this almost like origami looking flowers where things are. Well, as you can see here, because there's no constraints being applied properly, things are kind of flying off, but we can actually just get rid of those, I think, and retain whatever already looks pretty reasonable in the upper segment. So the way that I would do that, I would just take our group, Control D to duplicate it. I will delete the original group because we don't need the animation snapshot anymore. And I also don't think we actually need that to have this one as well. We're not going to use it anymore. So I'm going to delete, and I will also delete the associated enclosed to it. If I select all of these together by selecting one and then pressing arrow up key to select the rest of the group and then pressing Control 1, we can just kind of maybe manually take out this chunk. The easiest way would either be to bind them all together, or perhaps to just select all the objects. And if we press F11, our face selection should be on for all of them. So if I just grab whatever's here and then delete it, we have a cleaner section up here that we do not need to clean up any further. That's not bad. I'm going to take this group, press W to move it, just move it to the side. Really, I should have used something that's a bit less intersecting with the original mesh that we already had. But why not? We can have it as a copy and as a separate suit. I'm also going to use these ones that are intermediary curves and create a copy of the base and the line. That's good. And then we can align the group as well, because I have a feeling it is actually not aligned. I'll press D to move my gizmo by moving it in the vertical axis. Press D again to confirm the gizmo and freeze it. Oh, there we go. I think that's correct. Maybe not yet. Now it's correct. It's aligning with the appropriate segments. This part is quite annoying, so I might get rid of it. So I've selected one object, press arrow key up to select the group, Control-1 to remove it from selection, and F11 to step into face mode. I'm going to like try to select everything in this face mode like that, and then try to convert this to a shell. Delete whatever is underneath. Yeah, that's a bit better. Cleans it up a little bit. I'm also going to apply our custom polygon display onto this, which has now been saved, so we can like keep doing it automatically without resetting it again. That looks reasonable. So with this kind of mesh that we've saved, perhaps on like one of the back meshes, we can also try a little bit of cloth action, let's say. Let's select some of these faces again. I'm going to duplicate it, isolate it by pressing Control-1. I'm going to grab some of these faces and try a different operation of cloth on top of them. Not a bad selection. We might as well use something like this. I will remove the ones that are really massive, and I'll just focus on the ones that are a bit smaller by pressing Tab. That's not bad. Invert the selection, delete everything else, and leave these ones as they are. And we can subdivide this a little bit because it is looking really low poly. Let's see, hit once. Ah, that's fine. Let's hit, go crazy. This is looking quite good. So with this one, what we're going to do is first delete its history. And I'm going to convert it into an encloth. That's the same way I did with the rest of them. Go to encloth, create encloth. I'm going to fix the edges of it. So we don't want the edges to move, but we won't use pressure this time around. And let's see how that works out for us. So I'll select all the edges, go to select, convert selection to edge perimeter, and constraint, transform constraint to make sure that these edges are fixed. So for this one, instead of using pressure to kind of make it deform and expand, we're going to use the rest length scale of each edge. So each edge has this kind of initial length that it has. And it's always trying to kind of retain that length as much as it can, especially if the stretch resistance is quite high, like it's trying to retain what it has without like deforming too much and too unreasonably. So in order for that to change, we need to like instruct each edge to kind of grow in size, which will also create new deformations and intersections within the mesh. So in order to do this, we will select our mesh, which is now a cloth. We'll uncheck seal holes because we don't really need that. I will use very slight pressure just to stimulate the mesh to expand in the outward fashion. So we can be like 0.35 or yeah, maybe even 0.3 is enough, let's say. And then in addition to this we will also go to our dynamic properties and make sure that our rest length scale is not just 1, but over time changes. So in the beginning, it should be 1. We should just keep it that way. Maybe like we will allow for 100 frames, which honestly might be even too much for the machine. But let's say at frame 30, maybe it should be twice its size. And then we can set key again. Let's see how that works out for us. It might be quite slow. Okay, it's not too bad. Let's see if the results are anything interesting. Okay, so you can see that it's kind of like trying to deform while also like expanding. So it's not just a simple expansion due to pressure. It's also trying to push out because like it's almost like scrunched up fabric, right? Like all these edges are trying to expand far beyond their original size. and it kind of creates these like almost like ruffles within the fabric. I'm going to tweak this a little bit because I'm not super happy with how it looks just yet. So the collision flag, I'll make sure it's vertex face and make sure that this thing is very thin. So self-collide with scale should be 1, thickness maybe 0.1, and let's just check that out in our solver display if we switch it to self-collision. Yeah, it's actually looking still quite thick, so I think we can even go down to 0.2, for example. Then we will restart back and make sure that our cloth actually expands a little bit beyond twice its length. Let's go for 3. Might be a bit too much, but let's try. So I'm going to turn off my self-collision thickness just to remove it. And then I'm going to play again. And let's see how that works out for us. That's not bad. Looking a bit messy now. Maybe 3 was a bit too much. Not too bad. Still works. I just think that like the folds that it creates, like they look quite convincing. Nice scrunched up fabric. So I'm going to duplicate this as it is. Maybe just put it here. Again, let's align so we know that we have actually response. There we go. It is aligned. Yep. We have a little bit of a aligned. Does it look aligned though? Yeah, it is. Okay, so we have another version of how to control a mesh within cloth that is not just pressure. I think this one is quite nice because it creates like a better, let's say, wealth of ruffling compared to the other one. It also is quite nice in the sense that let's say the finer it is, like the finer the original mesh is, which we can also like test out, the more, let's say, detail you will actually have in the end. So if I just deleted our current enmeshed or like encloth that's attached to this copy of the Yangon, maybe we can reduce this further in order to test out what it would look like if it was even more subdivided. I'm just going to pick some of them, but leave the most intact. Okay, let's reverse this and just delete everything else. So this kind of reduces the number of polygons that we're working with, which enables us to maybe even add 1 more subdivision, which might be too much, but let's try. So in FX, with this greater subdivision, we can again turn it into a cloth. And affix our outer edges by going to select, convert selection to edge perimeter, transform constraint. Make sure that the collision flag for this type of deformation really does need to be better than just vertex, because when they expand, it makes it even more likely for them to intersect. So vertex face is really the only way to go. Collision can be very low, like the scale can be very low, as we've seen in the other one. So might as well use something less. This is fine. And then the Restland scale, we're going to move it really slowly to, let's say, 3. And I do think it would actually be interesting if the pressure was smaller and gravity did play a part. So I'm going to first simulate it without gravity and with very small pressure. Let's see. That's actually not really bad. It's working really fast. Probably could have grabbed even more. That's not bad. It's looking okay. And let's try to add gravity to it now as well and just see once they sag down if it looks interesting. So instead of our gravity being 0, let's place it to natural gravity of 9.8. And then let's see what happens. Oops, I didn't press play. Okay, so it's sagging down slowly, slowly, slowly. Before it reaches the end of the timeline, I'm going to stop it because I just want to expand the timeline. Otherwise, it just kind of resets and we have to do a lot of the stuff again. It's a nice bit of directionality to it. I feel like we could even afford a little bit of a more radical change in, well, this is really high. Oh, it's the wrong cloth. I think we can even afford a more radical change in the Restland scale. So let's try, instead of using 50 is 3. What the hell, let's just do 5. Let's see how that looks. Let's give it a bit more time. Nice. And obviously, if you want an even more accurate collision, you can even go for a full surface, although that might take a while. Nice. It's actually looking quite good. Go into 3 mode. And let's turn off this, what's it called? Like the edge display. Not bad at all. It looks nice. And we can attach this one just to the back of the other model. It does have some other competing geometry there, but we can get rid of that one and just give this one precedence. I am going to, instead of trying to visually match this, just match the, oh, actually it is already matched. That's so funny. Or maybe not. Nice. Okay, that's looking good. Maybe let's just try to clean out some of the other ones, of the old ones, out from the back, because we already have something that looks better. So I will go to face mode, control, right click, selection constraints, and change the propagation to shell. And let's just delete. Nice. Close and reset, object mode, and step out of isolation. Yeah, that's pretty good. Reasonable. Okay, Mike, so I'm thinking maybe let's take a break now because we've been at it for like 2 hours. Maybe like a 15-minute break would be nice. What do you think? Okay.
You hear me?
Yeah, I can hear you.
Yeah, I mean, maybe 10 minutes is fine.
Yeah.
Yeah.
Let's do that.
So maybe at 10, 20, sorry, at 20 of the hour.
Yeah, exactly. Okay,
Okay,
I'll
sounds
see you
good.
back in 10 minutes. Okay, hi everyone. I think we can continue on from where we left off. So I think maybe let's take a little bit of a look into the patch option that we also created. So I'm going to unhide it by pressing Shift H and Control-N. And I will turn on my edged shader. So wireframe unshaded, and change the display properties. It's a personal preference. You don't really need to do it, but I think it just looks easier to understand what you're working with. So for this one, I was thinking maybe we can do something where we kind of create like almost like padded elements where it's quite easy for us to kind of select these vertices rather than any others because they only have 2 neighbors. So we can create almost like these sails out of these patches. I'm going to create a duplicate of this patch. Press Ctrl+1 to go into isolation mode. I'm just going to select a couple of patches. I will not use all of them as we've done so far because it was a bit too heavy. So with Control and right click to selection constraints, I can turn my propagation again to shell and then just randomly select a couple of them. Actually, I might select these because I feel like torso is already covered in the sense of have a lot of geometry there, whereas the stomach area is not. So let's add a couple more. Yeah, might as well stop there. Although these are a bit of stragglers now. So let's add some to connect. All right, that's pretty good. I will also select these simply because I think I quite like the dimension. So Control, Shift, and I to invert and delete everything else. I'll add some subdivision to this because these are also quite low in subdivision. I might actually want to keep this edge sharp, to be honest. So let me step back and make sure in our smooth mesh option, if we double click it, that we use sharp edges and corners. Yeah, I think that's better. And now maybe after one more, we can just retain a little bit of a fillet. Yeah, not bad. So we can close this. So now if we were to turn this one also into an end cloth, I'm going to delete type of history because I want the subdivisions nodes that are attached to the object to go away. I'm going to turn it into a cloth. Like a lot of the processes are repetitive, but basically with very few tools, we can kind of tease out very different outcomes, which I think is kind of the strength of this approach. My propagation is still on shell, which is something I don't need right now. So I'm going to go to off. Go to vertex mode and select all the vertices, and then in geometry, go back to my neighbors and then activate that. Now we only want the neighbors or the vertices with 2 neighbors, which is basically these corner vertices. If we go to 0 for minimum and 2 to max and choose all and next, hopefully it should give us a selection pattern that looks something like this. So you're only like pinching like the edge vertices, nothing else. And then you can transform constraint those and just make sure that they are in place. If we rewind back, they seem to be in place. I can close and reset on the selection boundaries. And let's first try to deal with pressure and see what we get. Should be almost like a sail. Which is quite interesting. But then we can also try creating a minimal surface of sorts. I'm not really sure that the effect will be the best if we only have a vertex as a constraint, but we can check it out. I think it might have something interesting in it. So if I rewind back, press 1 in order to make everything smooth, make sure that my pressure is 0 because we actually don't need it. So for minimal surfaces, it also pays to turn self-collision off. And then increase the compression resistance. You can reduce the stretch resistance a little bit, and rest on the scale should be almost 0. Doesn't need to be fully 0. Not too shabby. Basically, what we're trying to do is create like these minimal surfaces in between these constraints of the edge vertices. And I think it doesn't look too bad at all. It actually creates an interesting output. But I'm now going to, perhaps because I'm quite happy with how this looks as a shape, we can even use this as an input shape for our encloth instead of starting from like a full-on patch, and create something from that encloth like later on. So basically, it's a good way to kind of, use encloths to create more variety. So if we just Control D this to make it as a frozen object, we can even get rid of the latest cloth. You don't really need it. And then use this as a new cloth. So the shape will still kind of be respected because it wants to be like something. Ooh, there are a couple of these that are not reacting that well. Possibly because there was another cloth that I didn't turn off and it's intersecting with it. So I'm just gonna remove it. So with these as they are, I'm going to just use this as my initial shape, create another encloth from it. And let's again constrain the vertices as we did before. So I'm going to select all of the vertices, go to Control, right-click, Selection Constraints, make sure that only the neighboring vertices of 2 vertices is selected, close and reset, Transform Constraint. Let's push these guys out a little bit just by using pressure. A bit more. Looks quite interesting. We have these like almost like minimal surfaces stuck onto the body. I'm going to control. We might as well try to give it an animation snapshot. Let's see if we can get a little bit more volume to it. I'm going to use 20 frames only, switch to my FX mode, and cache create, new cache create an object, which is going to be, I think, 20 frames because that's what we last used. That's pretty good. And then let's create like a animation snapshot of this again. Where are you? Animation, visualize, create animation snapshot. 1, 2, 12 swirly right, because it was like just kind of aimlessly floating in the last couple of frames. Apply. Not bad. Looks kind of interesting. So with this one, I think we can definitely take a look at this one once more. And we can just get rid of it now. And these are looking quite interesting in and of themselves. So I could actually imagine that if we were to use the entirety of the mesh, would actually create like quite an intricate model, but it might take a little bit too long to simulate right now. I will go back to my patch grid, duplicate it again, and take a look at what is left. And maybe this time we can change the approach a little bit. So instead of using what we had as like bordering vertex, in fact, we can actually try to use the vertices that are inside as a constraint. So again, I will use tab to randomly select some patches. Use Control, right click, and to shell to select those patches as full patches. Invert my selection by using Control, Shift, and I, deleting out everything else. And then now the vertices that we actually want are the ones that are contained in the center, not the ones that are contained on the outskirts of our object. So if we select all of the vertices and we press Control and right click and go to Selection Constraints, in all and next, you can actually choose the properties of the location of the vertex. So it's either off, on border, or inside. Obviously, if you choose inside, it will only choose inside vertices, on border, only the border vertices. Right now, we only want the inside vertices as they are. I'm going to close and reset. And then I'm going to create a set from these. And then in addition to them, I will also constrain these vertices as well. But before that, let's add some subdivisions to it. Oh, let's go crazy. A few more. Go to object mode, select vertices, go to set. So we'll basically end up with like a padded constraint in the center, but I'm also going to constrain the vertices that are on the edges. So if we select this object, turn it into a cloth as we did before. We have these vertices from our previous selection, which we still want. I'm going to transform and constrain them into position. But then I'm also going to use my selection constraints as I did before to also constrain the ones that are on the outskirts, because we don't want this like to move around too much. So in selection constraints, we can choose the vertices that have two neighbors. Close and reset, and then transform constraint again. In this case, I think there's no other cloth. Let me just check whether I've accidentally left one of the cloths. Whoops, that's a freeze. That was close. Let's save this just in case. Let's see if any one of the other cloths is still active. Ah, this one is active. I actually want to turn them off because I don't want them wiggling about and creating more problems for the solver. We only want the latest one. For now, I will leave all of these settings as they are and make sure that my seal holes is deselected and that the pressure is 5. This is also not bad. And it creates like a more padded skin on top. Maybe the pressure is a little bit too excessive, so I'm going to turn it down to 3. Like I said, a lot of this is eventually you'll find a lot of tweaking rather than getting like the result that you want on the first try. Okay. Let's say dismiss. Yes. All right. Let's save this one as well as one of the outcomes. Oh, there we go. And I actually think that this one might have like an interesting animation snapshot, because I can see that, you know, this edge kind of travels quite a lot from its original place into like an almost fully aligned position, which I think works quite well. So let's just see at which point in time it stops before it loops back, which is around, let's say, 11 frames, I want to say. So we want to cache out only 11 frames. So when I create my end object, I will actually go to encache, create encache, to the options of the encache. And this time, instead of using our time slider, which is the full 20 frames, I can actually just constrain it to 12, I want to say. I'm going to replace the existing cache because I don't care about removing it. And then go back to my animation and create a snapshot of that. 1 to 12 with increment of 1. Yeah, these are quite nice when there's like a lot of kind of openings on the side where you can actually see the cloth deform quite a lot. I will duplicate it by pressing Ctrl D and freezing it out, and maybe we can immediately even get rid of the old mesh. We don't need all of it to be there. I actually kind of prefer it to this one, so I will just hide the original animation snapshot. And this one can remain off. We'll move this to the side. Cover up a little bit of this space here. So in order to control like the end meshes, one way to do it obviously is constraints, but it's not the only way to introduce like activity into an existing mesh. Sometimes we can also use textures because they themselves can also apply different properties to the expanding or contracting of the mesh. So one way to do it, instead of using the constraints like we were doing so far, is to add a texture on. I'm actually going to use the basic mesh for this because the underlying geometry matters kind of less, and we actually want something that's quite well textured as well. So I'm going to take the base and duplicate it by pressing Ctrl D. Pressing Shift H, we will uncover the mesh, and pressing Ctrl 1 will isolate it so we only look at the mesh itself. So if we want to use textures in order to drive changes within the mesh itself, I'm going to work on like a subsection of it. I don't think we need like the entire body for that. So let me just kind of create some kind of logical break within the body. Maybe we can work on a section of the arm. So in order to just move the arm out and from edge mode, I'll double click where you kind of find this seam, and then shift and double click to close the seam completely. I might want to use this one rather than the other one. Just try to find something that is kind of a natural end for the seam of the arm. I'm going to detach all of these and then see, oops, it's still attached. So let's go to display, space, display, polygons, custom polygon display. This is where it comes in handy because you actually follow where it is that you need to break the mesh further. So I think I need to continue breaking my loop. I can break it here. If I detach this and double click this section, it still seems attached. So I'm going to break it on the other side as well. Okay, that's not too bad. It's a bit messy, so maybe let's include this section portion as well as the other one. So again, double click the edge, detach it, and then double clicking in face mode lets us kind of select out this segment. I think that's pretty decent. If I reverse it, we're using Control Shift and I can just delete. Press 1 to get like the normal mode, and then merge whatever I have here because I actually want this to be fused. I'm going to kind of remove this part that's part of the underarm, even though it creates a little bit of like a kink here, because I don't think it's necessary and it might mess with simulations anyway. So from face mode, if you type in if you left click a face and then follow that along a certain face loop, and then shift and double click the face that's in the associated loop, you can connect the loop fully and then just delete it out. Maybe let's finish this up as well. It creates a better seam. Let's say this section is not bad. I'm actually going to also remove the hand itself because usually it's more trouble than it's worth, especially when working with deformations. So let's just remove this part completely. Basically, we're working on something that looks like a sleeve. So in order to use textures rather than constraints to control this sleeve that we have right here, we need to apply materials. So if I select the object and then press and hold the right mouse button, I can assign a new material. The material itself doesn't really matter. It's only there to visualize where a certain property will lie so that we can actually understand what property we're attaching to what section of the sleeve. So if we choose the Lambert, which is a basic diffuse material within Maya, we can apply a certain texture to the base color of Lambert. It will automatically open in the attribute editor. And in these checkered boxes here, it basically means that it takes a texture of some kind. So in its color, you're going to take a texture and might as well take a ramp. If nothing changes within your screen here, try pressing 6, which will pull up the shaded texture display. This basically means that if there is a texture on top of an object with a material, it will be in some way visualized within the screen. It has an automatic texturing that is kind of like an unwrapped version of this texture. It probably works if you're kind of trying to attach a skin, but we only care about the pattern itself. So I'm going to create something that's a little bit more consistent, so we don't have like these seams that are kind of skipping from one color to another. So I will just use the very basic texturing method by going to the modeling tab. I'll just save now. I'm going to UV and just choose a planar texture. Basically what it does is it means that it's applying texture in the Z-axis. So I can see that my ramp, which goes from white to black, is doing so from like the back to the front of the arm because the mapping is in Z. Basically, I just wanted this like very clear delineation between the two colors. So in order to kind of play around with this color a little bit more, because right now it's not giving us too much, we need to go to our texture, which you can access either by using Hypershade, or the preferred method that I use is actually from the outliner. Outliner contains all of the elements within a scene, so it doesn't really matter if it's just geometry or a dynamic object or an IK handle. They're all there. It's just that sometimes they're occluded because it makes the entire outliner too populated. If you go to display and uncheck DAG objects only, you will actually populate it with every single component that is happening within your scene right now. And one of those will also be the textures. So the latest one that we applied is a ramp texture. And if you select it like directly from the outliner, you can kind of affect its properties in the attribute editor quite easily. So I'm going to like make this quite tight, like it's almost like switching from white to black quite aggressively in a way, almost like splitting it in half. But then there are other properties to a ramp texture that you can also try to exploit. Right now we are using a V ramp, which means that it's kind of distributing color in the V direction. There's always a U and a V direction, kind of like a U and a V direction in Rhino. If you're a Rhino user, you understand that there's isolines moving in different directions. Same with meshes, or rather UV meshes that are used for texturing. But if you add like a noise property, you can kind of see how it kind of allows you to mess with the way that the pattern is distributed quite a lot. You can affect the frequency and the amount of noise that it has. And you can also affect the wave, the U and V wave itself. So because this is a V ramp, we're using the V wave. And the more we kind of distort it like this, the more it kind of moves, let's say, basically this pattern is being applied rather than just a flat ramp. Right now, it's kind of the amount of differences, it's understandable, but maybe we want like something a little bit more ornate in order to kind of multiply this texture and like make it repeat more times. There's something also called UV coordinates. So UV coordinates is like a coord that controls how the texture is distributed on an object. And you will see that it has an active connection to it because it has like a planar mapping that we've applied to the object. If you repeat UVs, as you can imagine, it kind of repeats the pattern more times. So it gives you this like little zebra pattern. Maybe let's go for 4. Don't think that more would even make that much of a difference, to be honest. So if we go back to our ramp, we can affect how this is also interpolated. You can interpolate in a smooth or linear fashion, which means that there's like always a gradient between two extreme colors. But if you switch this to 1, it allows you to kind of iterate between white and black. That is it. So any kind of vertex or face that is located on top of your map that is in the black area will act differently to ones that are in the white area. So in order for this to work, obviously with a texture that has this level of detail, what you also want is a similar level of detail within the mesh itself. So obviously, if you kind of just try to apply a cloth on this, there's really not enough elements that are populating either of the zones in order to create like a meaningful deformation. So what you will eventually need to do with this is kind of create more subdivisions. We can kind of go a little bit crazier on the amount of subdivisions here because I've only isolated like one sleeve. It should not be that big of an issue. A good way to kind of keep track of the number of faces that you have is using poly count as your heads up display. It will kind of inform you if your expectations maybe of your machine are a little bit unreasonable. So in a way, you can kind of select faces and just make sure that the amount of faces that you're trying to simulate is not unreasonably large. You can turn this on by going to display and then going to heads up display and then turning on poly count. Poly count will basically just kind of create this a little heads up display here, and it will tell you how much of each element there is in the scene. Like the first column is telling you like the amount of faces within the scene, which right now is pretty massive considering how much we worked, but it also allows you to kind of select it out. And from the third column, you can see the current selection. So right now this has 35,000, which is quite a lot, but let's try to simulate it on top of it anyway. It's important to do this texturing process before applying the cloth because you want to affix this texture to the vertices and to the cloth in a way that it kind of doesn't shift when the cloth itself moves, because there's a planar texturing map on top of this. So if you do it after you turn it into a cloth, it will shift around and you will not have a meaningful result. So now we have this object. I'm going to my outliner and I'm going to check DAG objects display again only, just to kind of depopulate the outliner itself, and then go to FX and create an end cloth from this. If I create an end cloth from this and I just play it, it will play out in the same way that the other ones have. You'll just start falling, nothing really happens. It's just being affected as a cloth like the ones that we've created before. However, in our dynamic properties, the way that we affect the properties can be numerical, where the property is applied to the entire object. But you also have a subcategory of this drop-down menu, which is called dynamic properties maps. So basically here, a color of the map is then added as a multiplier onto a certain property, which allows you to control, let's say, the amount of restline scale or stretch or certain type of deformation resistance, which is concurrent with the color that the vertex is occupying on the texture. So black means 0, white means 1, because it's like 0 and 255 in RGB code. And basically that is the multiplier with which you are multiplying a certain property, which you can affect within the dynamic properties maps. So if you're affecting, for example, stretch, a stretch in dark areas is 0, and stretch in light areas will be whatever your stretch resistance is set up as here. So that will basically create a material that behaves differently in different sections, and you don't need to use constraints, you only use the map itself. So in order to kind of show how this works, we can use restline scale, because I think that kind of creates the biggest sort of difference and makes a lot of sense once it's being used. So the rest length map needs to be informed by the ramp map that we've introduced into the scene. I will uncheck DAG objects again, just so I can navigate to my ramp map. In order to create a connection, you would use the middle mouse button and hold it down over your ramp 1 texture, and then hover it until it reaches like the text that describes the property that you want to affect, and then you just release it. For now, I'm also going to, again, turn on DAG objects only, and in my nucleus, I will kill the gravity. We'll have enough forces to worry about even without gravity. So if I was to play now, you will see that the result would be quite weird, because obviously like these black areas are trying to constrict to the 0 value of their size, which does make a lot of sense. Essentially, it's much better to kind of work with shades of gray in this sense, because like no material will stretch that far. So we can affect our ramp by making sure that this is, let's say, half the value of black, because that basically means that these areas will try to contract to half of their size, which is a bit more reasonable. So there will still be deformation, but the deformation will happen in a way that kind of makes more sense, to be honest, rather than how it did before. So obviously you can tell that the higher the resolution of your mesh, the more interesting the output will possibly be. And considering how fast it's moving, I think we can even afford a little bit more of subdivision, but let's for now just keep to this one. So if I also add in, let's say, to our cloth, I'm going to turn off the other objects. If we also add a little bit of pressure, it will hopefully try to expand more in the white areas. And what we can also do in order to kind of, I guess, sort of exacerbate this further, is to create a texture map that will also affect resistance. But let's just try to reduce resistance first and just see what that gives us. Oop. Should not have increased that immediately. Let's keep it at 5 for now. That doesn't look bad. So basically what I actually want is to create stretch resistance in white areas, which is in fact lower than the stretch resistance in the dark areas, so that it kind of creates a little bit more give when pressure is applied in the white area rather than the other way around. So we kind of need like an inverse of the map that we already have. So in order to do that, we can go uncheck our DAG objects again, create a duplicate of this map by pressing Ctrl D. And in this one, we actually want the colors to work in a reverse manner. We still want the colors to be in the same place where they're supposed to be, but they just need to be inverted. And then if we navigate back to our end cloth and go to our stretch, we can drop the second ramp onto the stretch. Let's try again. So this is working a little bit better because we can see that the stretch on the white areas is becoming more prominent than the stretch in the dark areas. I'm going to increase the stretch resistance a little bit because we're already trying to affect it with the second ramp. And we can make sure that this is like almost like negligible stretch in order to achieve like maybe like a more prominent deformation, which is kind of working out not bad at all. So you can see that it's kind of trying to struggle to create like a different subset. You can also see that because this, let's say this ramp is linked to a different patterning method, you can actually see that it doesn't fully align with this map, with the one that we copied. And this is because it's not linked to the same UV mapper. Luckily for us, in this case, it actually kind of makes it work because it actually looks quite nice even without it. I think this is looking quite good. Although the amount of stretch that it gives makes it inflate a little bit too much. So it kind of looks too massive. I think the good way to kind of avoid this would be to apply initial pressure that is much greater for like a shorter amount of time. So maybe we just like crank it up to 4, but not allow it a lot of time to move. Maybe even more. Let's see how that works. Whoops, that was definitely too much. Let's try 3. seems that only lower options would really work. I think I'm letting it develop a little bit too long. Maybe 6 is about the limit. Oh, not bad. So we have like one sleeve. I'm going to duplicate it. And I'm going to duplicate it actually again so that we have a mirror of it. Pressing R for scaling, holding down J for symmetry, or stepping rather, and then just pulling the axis through itself in order to create a duplicate on the other side. It doesn't look bad. And it's actually like a method that we can apply on other segments of the mesh as well. Oops, I have made a mistake. This one is the active cloth, so that one cannot be moved. These two can be moved. Let's add them to one of our mannequins. Not bad. Let me just change the display. Custom polygon display. Oops, definitely not. This is way too high poly already. It does not need more subdivision. So this is like one of the ways to also affect the cloth without actually having to put in any constraints, or rather just use textures as constraints as well. There's other options within the constraints as well that can be affected, which will work in different ways. One of them being wrinkle. So for example, if you've kind of created the cloth, you're happy with what you have, but you want to like try out other versions of control, I would kill the pressure first. And then you can break the connections between the existing maps. So the stretch map can be kind of removed by just breaking the connection, and same can be done with the rest length. We might try to do the same by using a wrinkle map. Let's see how that would work out. So instead of, I'm going to use ramp 1. I will select my current encloth, which is encloth 5, use ramp 1, and drop it on the, it's actually outside of my scroll down menu. So scroll down, it says wrinkle. Put it on wrinkle. You can kind of see what it's trying to do. It's actually trying to move these faces in that direction. And as a result, the cloth needs to kind of, in a way, negotiate what's happening with the rest of the cloth because you're introducing this wrinkle. And the wrinkle might work a little bit better actually if it's not working with like an interpolation that is none, but rather with like a smoother one. I'm also going to make it darker. And then the interpolation will be linear. So it's kind of like a more smooth version of the deformation. So we can kind of see that like it kind of works really intensely where it's dark, and then where it kind of tapers out when it's gray. Let's try to tweak it a little bit more just to see what we can get. So if we symmetrize this, we might be able to kind of avoid instances where the wrinkle is quite severe. And create something a little bit more subtle. It's actually working a little bit better than the sharp ones because it creates a little bit of a gradient of influence between the two. And changing the interpolation will definitely change the outcomes as well. So it kind of allows you to almost sculpt the mesh a little bit more while you're working on it and just use the texture itself. The good thing about it is also the textures are keyable. So these textures don't need to be the same over time. Their noise or their UV change can change. So basically you can start with something that's going in one direction, but then if you change the UV chord, you will actually try to update the object and switch into a different direction. obviously, the more you work on this, like the more you need to tweak, because you want to see like the effect that it has. It can get quite messy quite fast. So also you can introduce a sort of controller to the wrinkle, because wrinkle map scale also can be used to kind of affect it more or less and create a more severe reaction to the wrinkle. I would say for the wrinkle, it might be useful to actually change the collision flag, because this flag probably ends up with a lot of intersections. Thickness is also quite extreme, but let's try with a vertex face collision flag with like a lower thickness. Don't actually want too much of it to be visible. I will hide these for now, just so we can see properly what we're working with. Still a bit too thick, but let's try. Why not? Turn off the display. Try again. So part of the reason why it kind of jerks so quickly, obviously, is the scale of the map as well. So we can kind of try to control it a little bit more by introducing a soft introduction of the wrinkle. So if the wrinkle is at 0, it like bears no effect to the object itself, but we can maybe change that over time to 2 and expand our timeline. And just see how that affects our wrinkle if it's a little bit more subtle. Actually, it works a little bit more nicely because the control works out in our favor. So obviously, like, this is kind of what you can tell from this type of design. It's very time sensitive. So obviously, if you change anything within the timeline, the design output changes quite a lot. So it takes some getting used to actually start thinking in a way that is more time dependent, or in a way works with like the dimension of time, not just with spatial dimensions. So now when we've kind of created this sort of output where it's wrinkled out in space quite a lot, maybe, you know, at that point in time, we can also apply some pressure just to get a little bit of a deformation out of it, maybe even more. To kind of like smooth out these ridges a little bit. I'll Control D to duplicate and then to have a frozen object. And maybe we can kind of clean this up a little bit more, or sort of accentuate the deformation by pushing all of the faces in their own axis by using transform constraint. So Shift, right click, transform component. Just subtly push it out. Or maybe even in would be nice, but let's see. In. Oops, no. It does create a little bit more of an accent to the edges themselves. I'm going to remove the subdivisions by pressing page down, and then just pressing like several times until you get to a 0. Press page up just once, and then type in 3. Yeah, it's actually not bad. It also gives the texture a little bit more richness, because it gives like these smaller wrinkles in certain areas to kind of make it look even more believable. Let's rewind to the beginning. I'm going to move this one on the side of the other one. For comparison, this one is proving a little bit richer because of the difference in maps that are kind of being bound one to another, and intersecting with each other. And actually, when you remove the shaded mode, you actually see, or like the textured mode, you actually see a little bit more the effect that it has on on the geometry itself, which is quite nice, like this kind of constraining element of the pattern spinning around your object, especially in these areas where the expansion is a little bit more obvious. So there's like competing geometry expanding in both directions and creating these like saggier elements. So this is like the second option of controlling the cloth. Like you don't need to use constraints, as I said. It can be done with texture as well. And I would also like to kind of look into another dynamic object within Maya that is paired with cloth, even though necessarily they don't behave in the same way, which is basically the particle engine. The particle engine is quite good at creating like effects that have something to do with like fluid-based elements or like anything that's particle-based. So it also creates a good opportunity to create like a nice texture and geometry, which doesn't originate from modeled objects. It's more objects that are completely simulated. So in order to kind of work on it a little bit, we can choose a base mesh that we want to use as an emitter, which in this case would be the body. I think the best way to go about it is probably to use one of the subdivided meshes so that we can control which areas of the body emit the object, which can also be done by textures. But let's see which one would be the best. Probably the diagrid one, if I use Control D to duplicate it, Shift H to unhide it, and Control 1 to isolate it. I'm going to select a couple of segments of it, perhaps something on the stomach, and maybe this one on the thorax. Reverse by pressing Control Shift and I and deleting everything else. This will be our emission object. I'm going to subdivide it once just to kind of create like the base for our particles to appear. And this is basically where the particles will originate, and then where they move in space afterwards will be dependent on the forces that we introduce into the scene. So in order to work with particles, because we worked with cloth so far, I'm going to turn off all cloths because particles and cloths actually interact. And because we don't need them to interact at this point in time, it's actually easier to just turn everything off because you don't want the computer to be overburdened with solving collisions that you don't necessarily care about. I'm going to go to Edit, Delete by Type History for this object. And then I'm going to emit particles from the object. Because particles are a bit more, let's say, uncontrollable, I'm actually going to emit it only from one side, and I'm going to symmetrize whatever the result is. I'll press space and then switch to 4-view mode. Then hover above the front view, press space again. Press Control 1 in order to isolate the carapace. And then I'm going to only select one side and delete it. So this side, the right-hand side, we can just delete. It doesn't matter if it kind of has these faces that, you know, kind of end up looking a little bit scraggly. It will not be that important. So I step back into a perspective by pressing space and then hovering above perspective and pressing space again. And what I want to do next is go to my FX, go to End Particles, Emit from Object, and choose the option box. So in the option box, you will have basic emitter attributes, which will refer to how the emitter is created. The emitter type can be omnidirectional, surface, and curve, and they're kind of self-explanatory in a way, I suppose. So we want the type to be surface because we want the particles to be emitted from the entirety of this object. The rate of the particles, you can leave it at 100. The speed is also fine. The rest of the properties can be left as they are. And then you apply. Once you apply, you will see that next to your, or like in addition to your object, there's also like a little particle cloud being created in your outliner, which is where your particles actually live. But attached to the object, there's also something called the emitter. The emitter emits the particles and actually brings them to life, let's say. And the particle cloud is what you can use to kind of surveil what your particles actually are. The emitter in its attribute editor will contain information about the rate, the kind of emitter it is, the rate of particles per second, whereas the particle shape, or the particle one that you see here, will contain all of the dynamic properties of the particle, the same way in which the cloth does. So basically these two objects are the same object, but for different subsets of simulation. So if I go back to control one, I'm going to try to clean this up a little bit because there's so many competing geometries by just hiding whatever we're not currently using, which apparently is quite a lot. And then I'm going to play in order to show you the first. So you can kind of see there are these little tiny points that are leaving the mesh and they're kind of heading in their own direction. So these are the particles being populated into the scene, and they're being populated at a certain rate that is dictated by the emitter, and a certain initial speed or force that again is dictated by the emitter. I'm going to go into the particle shape and make sure that the number of particles that I allow to be emitted into the space are actually not too big, because we're going to attach newer clouds to the existing ones already. In order to control the number of particles that are allowed to be emitted in total, you need to go to the particle shape, go into the attribute editor, and then in count, you can see the current count is 404, but in emission attributes, you can see that the max count right now sits at -1. This basically is like a trick to kind of tell your computer, just keep emitting them forever, however many there are. But if there's any kind of positive number here, like 10, for example, it will emit 10 particles and then will stop. So there's 10 particles now in the scene. It's not too many, but it will not do more than that. I will put in, well, maybe let's say 35. We don't need a lot, and it's something that we can change later on anyway, so it's not too important. So these particles are just kind of like moving out in the direction of the normal of the face from which they originate. So they're not doing much, to be honest. But there's force fields that can affect them to move in different ways. So to create a little bit more of an interesting pattern of movement. In order to affect them with these forces, you need to select your particles, go to fields and solvers, and then add a turbulence, radial Newton, or any of the forces that are available to your to affect. These forces, conversely, will also affect cloths and any kind of N object, really. And hair is also considered an N object. So in FX, if in case you're in a different modeling or a modeling tab, you will have fields and solvers. You can apply a turbulence field, open up the option box, and you'll see that most of these are okay as they are, and you can also affect them later on anyway. So I'll just click apply. If you play now, you can't necessarily see anything yet, but if you increase the magnitude and decrease attenuation, you'll see that the particles start to like kind of ripple out quite fast. So it kind of gives you an idea of what turbulence does. It introduces forces of turbulence within the scene, which forces the particle to move in different directions. So attenuation refers to the rate of decline of the intensity of the force field. So the smaller it is, the more uniformly powerful the force field is. Whereas magnitude, obviously, as the name suggests, refers to like the strength of the force field itself. This type of force field also has an interesting property of frequency. And I think if I changed, it's easier to understand if you just see the change itself. I will, for the purposes of this, increase the max count to, let's say, 250, just so it's more clear what it is that it does. So in our turbulence field, the frequency is 5. The particles move like more in a sense where it's like, let's say that the field feels really dense. There's a lot of change within the direction within the field. But if the frequency is really low, like 0.1, imagine that the swirl of the particle or of the field of the particle is much larger. So the particles seem to like kind of congregate, even like follow directions that seem like they're kind of the same. So you see, the smaller it is, the more likely it is to like kind of follow a uniform trail. And the larger it is, the more likely it is to like kind of buzz around quite in a quite high frequency. So in order to visualize this even better, because sometimes it's hard to see, we're going to make sure that these particles actually leave a trail behind them. The easiest way to do this is to attach another particle cloud to them. So if you select the original particle cloud, which we're going to call the parent or the guide, you can go to M particles again, emit from object. But this time you're going to change the emitter type to omni, because particles can only basically emit from a point in space, because that's what they are. They're not really surfaces. The rate, though, needs to be a lot lower, so we're going to make it 10. Speed, we're going to actually make 0, because this kind of second layer or second cloud of particles doesn't really need to do anything other than index the path of the already existing cloud. We don't want it to like have any dynamics of its own. So when you first play it, you can kind of see that the particles are leaving like little traces behind them. And that the bigger the rate of change, the more you will actually be able to see like the particles themselves align. So what I'm saying is that the second cloud, we need to make sure that it has as little activity as possible. It's only there to index what already the guide cloud is doing. In order to do that, we need to go to particle cloud number 2. You can see that there's an emitter now attached to your particle cloud 1. So with your particle cloud 2, what you can do is dynamic properties. You can make sure that the conserve is 0. Conserve amounts to the amount of force from the previous frame that is being led into the next frame, and it kind of affects the particle's ability to switch positions, let's say. And the other thing that you want to do to it, you make sure is that it kind of doesn't really recognize collisions or forces in the scene. So collisions should be off for this particle. We don't actually want it to collide with the parent. We just want it to index the position in space that the parent had at some point. And we also want to make sure that it kind of ignores gravity, ignores wind, and ignores forces in the world by unticking forces in the world and ticking the other two. So nothing that is happening in the scene is actually affecting this particle. In order to kind of make it a little bit more apparent, I'm going to increase the emitter rate for the second emitter. So you go to particle 1, which now has a drop-down menu. You select the second emitter and make sure that the amount of emission in it is actually larger. So let's say 35, which might be a lot, but let's see. And you can actually see like the trails are now becoming more apparent. The other thing is that it kind of looks really fuzzy right now. There's like a lot of direction, things are going every which way, it's not really clear. This is also because a lot of the original particles have confused forces at play. So selecting the first particle cloud, I'll go to the attribute editor again, and this time I'll go to dynamic properties and make sure that the conserve here is also very low. You can even be 0. If you play it out now, they don't move a lot. They kind of just move within the local area. That's because the only force that's now being allowed to affect them is the turbulence field itself. And the turbulence field that we have has quite a high frequency of 2. If you move that frequency to 0.2 or 0.2, basically, you will see a little bit more kind of unified movement. They kind of belong to their own swirls. This also means that the magnitude can increase because they are quite slow. So let's say 350. And see what happens then. It kind of creates a nicer, more controlled swirling of the particles themselves. And obviously, as you kind of decrease the frequency even further, the swirls become even more unified. Let's see. they're heading also in a direction that doesn't fully work for us, but luckily you can always change this by randomizing the field a little bit. I think we would benefit from it moving a little bit differently. So we can change the phase of the turbulence, and it will change the way that the turbulence works as well. So it's a bit different from the last one. Every time you make a significant change, they will kind of change direction or how they move. Noise level will also affect their movement. But let's say this is not bad in a sense. I think what would help it is if we had perhaps a few more guide particles. It seems that the numbers are a bit too low. So we will go to the particle cloud number 1, which is the original one. Go again to emission attributes. 250 is the max account. It's actually not bad. Probably the rate of emission is so slow that we need to wait quite a long time in order for all of them to get out there. So I'll go to the emitter for the particle cloud 1 and actually increase that rate to 500. So we basically just want more particles to appear at the same time, and we want them to freeze whatever they are at that point in time. That's not looking bad. It looks quite nice. So the reason we have the index cloud is because we actually want to kind of create geometry from this as well. Right now, the way in which this is displayed is just like a point in space. It doesn't really have any geometry attached to it. It doesn't look like anything special. So in order to change that in our index cloud, which is our second cloud, we need to change the way that the particles are represented and shaded. So in attribute editors, when you select end particle 2 in shading, you will have the type of shading to switch to from point to sphere. If you switch to sphere and you zoom in, you actually see that each particle is described as a sphere. And the thing with them is that they also have dimensions, right? So you can link a certain property of these particles, like their size, to a certain property they already contain, like, let's say, their age. Obviously, each particle that populates into the scene is different age, right? Like, depending on the time in which it enters the scene, it's younger or older. And this can be used as a valuable property for us to actually control their size, their color, and so on. So, for example, if we wanted to relate the age to the size of the particle, we would need to select our second particle cloud, which is the one that deals with like just the indexing. And then I'm going to collapse all of these so you can see them a little bit better. In the attribute editor, there's something called particle size. The radius scale of this particle size right now is, let's say, constant. Doesn't matter when the particle was made, but the rate of change for it is basically constant. You can change it to a, let's say, declining function, but you also need to give it an input. So it needs a certain property that it can measure, that it can map to this kind of declining function. So in this case, I'm going to choose age. If I choose age, you can see clearly that from the graph that I've described, everything that's very young seems to be a bit bigger, whereas the older particles, they actually start being quite thin. So it makes sense, right? Like moving from one side to the other, the age is increasing, but the size is decreasing. Input max kind of maps where that age gap starts. So if you kind of increase it, particles are allowed to be bigger for a longer period of time. I think what would work better probably for this is to reverse this logic. Every time you click anywhere within this graph, a new point will appear. You can delete old ones and add new ones, and it will describe the rate of change of your particle size throughout the simulation. I'm going to increase the radius in general so that we can have a little bit more of a radical view of like what our particles look like. And we can perhaps create like a function in which, you know, at the very end, they also become large again, and then tweak our function until we get something that's quite nice. Maybe even this can be even a bit bigger. Maybe it's nicer if I just keep it simple and let them decrease in time. And by playing with the range, we can change how much that affects it. So we always start with these like really large ones. Like the older they are, the larger they become, basically. The other thing that we can also do in order to kind of add more interest to this is to add in a little bit of color into the particle cloud as well, which can again be based on the base of age. So in this case, we will need to navigate to shading, where we switched from points to spheres. And in the sub context of the shading, there's something also called color. Right now, the color is constant. We can change it to age, but then we also need to give it like color to map to. Right now, we only have white, so there's nothing else that they can map to. But if you click in somewhere in the white rectangle, you can add another data point. Let's add 3 in total. In order to change this, we can open up the dialog box with this little arrow pointing to the right. And it will give us like a ramp or an internal ramp where you either remove a point by pressing the square with an X, add a point by pressing somewhere inside, or change a value by pressing the circle and then going to selected color and giving it a certain color. So let's give it blue, or cyan rather, and hot pink and white. So obviously now the input max matters here as well. As you slide it along, the color of the particles will change. And if you slide these data points along, it will also change where exactly or how gradual or how abrupt, let's say, the change is. So maybe it goes from white, hot pink. Let's play it again. There we go. As it moves on, you can also see that because a lot of them are quite big, we can maybe even get away with like a smaller emission of the index particle. So if we go back to our initial particle cloud and we find our second emitter, maybe this could even be 10 and we could get away with it. Basically, the reason I'm trying to compress the number of them is because obviously the less of them there are, the lighter it is to simulate this. And once they kind of grow, they kind of start intersecting anyway. So there's really no need for it to be more than 10, 15 maybe. I'm going to expand my timeline to 400 frames just because I don't think that this is quite enough. And I'm going to also expand the number of particles that I have in the original cloud because I've cut down on the other cloud quite a lot. By going to my first particle shape, attribute editor, emission attributes, and making sure that this count is maybe 350. Let's play it again. Not bad. Play a little bit longer. Yeah, actually it doesn't look bad at all. And then we can also, maybe let's tweak the colors a little bit. I think there's too much of pink right now. Shading. And let's change the input range. It's looking quite reasonable. Let's show our base mesh so we understand how it sits with regard to the body. Not bad. We can also work a little bit more on our turbulence field. I do think that we could benefit maybe from changing the phasing a little bit until we have something a bit nicer. Oh, this one might be better actually. And then let them develop. Not bad. Perhaps the rate of emission of particles is a bit too low now. I'm going to increase my second emitter a little bit to 15. That's better. So obviously, like every time you change the turbulence field, you'll have a different output. So it's quite prolific in terms of creating different outcomes. You can also perhaps create a little bit of a more interest or more accuracy, so to speak, by making sure that particles do bounce off of the body, because right now they are kind of intersecting with the body as they move, which doesn't make for like the best result maybe. So I think one way to kind of keep that neat or clean is to turn this object into a passive collider. So what a passive collider does is like it's a static object, but n objects do interact with it. So if it's in the way of an object, then an object will react to it in some way. I'm going to create a duplicate of it, hide the original one by pressing Ctrl H. And with the duplicate, I'm going to offset it in a little bit because I know that where the particles originate actually on this object is directly on top of the emission object right now. So I'm just going to pull this in a little bit by selecting all the faces, Shift, right click, transform component, and just like pull it a little bit in. It doesn't matter if the object itself is looking a little bit weird, as long as the majority of the volume is not intersected with, I think it will look much better. So in FX, this object should now become a passive collider. So in an encloth, you can create a passive collider. Technically, they should not collide anymore, at least not the guide particles, because we have removed all collision essentially from the ones that are index particles. And you can kind of see that once it kind of hits against the face here, it still tries to follow the turbulence field, but it doesn't really allow it to intersect with the mesh, which kind of allows for, I think, a better result. This is probably going on for way too long for what it is. So what I'm going to do is further increase the turbulence field to like maybe 800 even, and then replay the simulation. This is even enough. It's just that the rate of the emission of the index cloud needs to be quite high for this to work properly. So I'm going to put this at 45 maybe. Let's see how, if that's too dense. No, I could even afford more. Let's try 120. Not bad. I'm going to stop it here because this is a lot of it already. And I'm going to set the properties of the second cloud so that we can kind of thicken it up and choose the color a little bit more wisely. So input max, I need to like reduce in order to like thicken up the particles. And then in shading, input max for color also needs to be reduced in order for the color to come through. Yeah, it does not look bad. Let's replay it once again. That's looking decent. Maybe the input max for the color can also shift a little bit because there's, again, too much of the pink. Oh, there we go. Let's add one more color in between. Something that offsets it a little bit. Be yellow. Not bad. So perhaps like once this is created, you would like to like migrate the model somewhere else. The best way to do this is to turn this into a mesh, which particles can do. There are quite a few here, so I'm going to save my scene before I attempt to convert it. But the particles will allow you to turn them into a mesh, like a fused mesh that you can actually export into other platforms. So it doesn't need to remain in Maya only, because a particle as an object is an object native to Maya. It won't really work anywhere else. So in order to do that, if we're happy with how our scene is right now, I will save it just so I have a copy of it. Our particle cloud number 2, we can select it, go to our attribute editor, and then in there should be an option here that refers to meshing. Let me just collapse all of the profiles, and then in output mesh, these are basically the attributes that your mesh will have once it's created. For the first try, I think this is quite fine to leave as is, because then you'll be able to kind of see what it is that you need to do in order for the mesh to look more decent. And what I would also recommend is also controlling that the color per vertex is enabled, because that will actually enable you to use the color of the particle to embed color into the mesh itself, because the vertex of the mesh will inherit the closest color of the closest particle at the point at which it was generated. We can untick velocity per vertex, that's not needed. So in order to do that, we select our particle cloud, press space, go to modify, then convert. And in the convert options, there should be one that says N particle to polygons. You can choose that one. So the first try, it kind of looks okay, it's not too bad, but it loses quite a lot of the definition. The first thing that I would do is turn the triangle mesh into a quad mesh instead. And then this quad mesh can also be smoothed out a little bit. Right now, because you see the logic in which the mesh is created is that the space gets voxelized. That's why you're seeing all these almost like faceted elements that align to boxes or voxels in space. And the fineness of this voxelized space actually affects the fineness of the mesh itself as well. Smoothing iterations can help it if you put it to like smooth out the existing output, so it kind of looks less boxy, which does help quite a lot. But the best way to control the, let's say the how like detailed the output is to try to work with the threshold and mesh triangle size. So this size, the smaller it is, the more you're allowing the voxel to be small, the finer the result, but the longer time it will take for it to be computed. So if I put this at 0.3, it will recompute, and you can see like it contracts a little bit. So 0.1 will contract even more. So blobby radius scale and max triangle resolution also obviously affects how this gets meshed. Right now the max resolution is 100. If we up that, it will respond to the need for the mesh triangle size to be smaller, and the output mesh will actually become more detailed. Obviously, even though it's more detailed, it also means that it takes a little bit longer for your computer to calculate it. So you can see that there was a bit of a lag after I input the final resolution. I think we can push it maybe to 250. Let's try again. You can see like every time that you kind of add more, it takes more to calculate. I think 250 was probably going to be either too much or I think that's quite decent in terms of detail. We didn't lose much from what we had originally, I think. Threshold, everything else feels correct. There's no loss or stragglers. So this potentially could be okay. So if you want to see the colors again, the way that you saw them in the particle cloud, you can select the object, and then in the same place where we were kind of affecting the smoothing levels of a modeled object, there's a bunch of other stuff within attribute editor that affects the shape node. And one of them is also the mesh component display. Within mesh component display, there's also something that displays colors. The way in which the display colors, it can be applied through a color channel. So ambient and diffuse, or just ambient, like you will see which one works best. I think diffuse is enough. And it will kind of give you like this preview of colors within the vertices themselves. So you can actually see that this object now, if you were, before you kind of replay or rewind your scene, because now you're basically telling the particles to mesh every frame as they are being populated into the scene, it's best to, duplicate this so you have like a fixed version of it. Because the second you rewind, this original mesh will disappear because now no particles are still in the scene, and you only have the copied mesh that you can actually copy and obviously symmetrize, which kind of creates like a nicer output. Kind of does look like a suit of a kind. I'm going to just slide this over to the side. There's a lot of competing geometry in this one. Maybe I'll just keep it separate. This one, I believe we can just get rid of. So fun. So obviously this method can be used as I used it in other examples, more on a localized scale. And I think it will probably work better that way if you kind of, especially if you're working with something that's not as easily controllable like particles are, it's probably best to break the model in different areas and then like give it a chance to kind of adjust a little bit better so that you can still, in a sense, identify what's an arm, what's a leg, what's torso, what's the head. So I think you end up with something that has a bit of a better output. So the original particle cloud, now you'll see if you were to play, it will get quite heavy quite fast because it will attempt to mesh this particle cloud in every frame that you play. So the more particles that are populated into the scene, the slower this will get, and eventually will get really, really slow. So it's best to know when it is that you are happy with your particle output before you convert it into a mesh, because it becomes quite a difficult thing to control it later on. So right now, because I don't really need it anymore, I'm just going to delete these clouds. I think I'm fine with them being removed from the scene. But I got one more copy for free. I'll leave it here, even though it probably completely aligns with what's already there, so it won't look that great. There we go. Maybe let's just delete it. It's a good method to kind of create like traces, especially because you're tracing particles that are actually moving in space, which you can affect by forces. Turbulence is only one of the forces. The other ones are also contained within the fields and solvers, and you can use any of them to move your particles around. The best way to index them is obviously like having a separate particle cloud on top of it. So I think like, let's take a look at what we have right now and maybe plan out our next step. So I think we can take a look a little bit into more modeling-based solutions as well. So while texturing really works for nCloth in terms of kind of creating constraints that are not constraints, but there are other differences in applying certain property to the cloth. There's also things that you can do modeling-wise that will help you out, even though your topology might not be the most exciting one. The easiest one of them being the texture deformer, actually. So the texture deformer allows you to use a texture in order to move vertices around. And by moving them around, you actually create a lot of opportunity for deformation within your object. So texture deformer, again, is dependent on how you're actually texturing the object itself. So I'm going to use this base, which is an N-rigid. N-rigid is a vestige of our passive collider. I can just remove it. We really don't need it anymore. And it was tied to this object. I will isolate it, assign an existing material to it, and I'll assign the Lambert 2. This is the same Lambert that we assigned to our cloth in order to kind of create wrinkling deformation within it. If we hit 6, It'll just take a while to update. We can actually see how it's being applied to this figure as well. Right now, it has its own basic texturing. I'm going to go to modeling. And again, like I did before, I'm going to apply a planar modeling. Planar modeling or planar texture map. So basically what I'm going to do again, I think for this one, I'm also going to work on a section rather than the whole body. I don't think it's necessary, to be honest. So let's say I'm going to make a few selections in the torso. And then by using shift and greater than, let's just grow that selection. Maybe something like this. Or rather, let's work within this area, the midsection, because we've kind of been avoiding it a little bit. This is looking almost like a corset. So Control Shift and I to delete everything else. That's not bad. And for texture deformation to work, again, you need a little bit more of a bit more of subdivisions, really. So I'm going to increase the subdivisions. This is perhaps enough, maybe even too much. So we can use this texture map that we have in the background in order to deform this object. The way that we can do that is by selecting the object itself, going to our modeling tab, and then in the upper ribbon where properties always change when we switch between sections of Maya, there's one that says deform. Deformers come in many shapes and sizes. So like there's different deformers. They're usually used for animation, but one of them is a texture deformer. And if you apply it, at first nothing will happen because there's no input texture that is being used. The first thing that you need to affect is leave the point space in UV. Direction should not be handled. It should be normal. So basically it's saying the direction of deformation for each vertex based on the texture will be in the normal of the associated face. So if we now navigate to our texture, which we already have in display, and then uncheck DAG objects only, I believe it was ramp 1. So if I middle mouse button click it, and then just hold down and then hover above where it says texture and then release, you will see that it's starting to like deform the object. So wherever it's dark, it moves very, very little or not at all. And wherever it's light, it's trying to push out by this amount. So if you change the strength, obviously you can also reverse the strength, but if you change the strength to like 2, this is kind of trying to deform by that much, like by 2, and retain, let's say, the position where it's black, because that's 0. This is also nice because it updates, oops, wrong ramp, sorry. It will also update as you are changing the ramp here. So it's easy to use to iterate different texture outcomes. And by adding noise frequency, you can actually create quite nice, I think, outcomes in terms of the richness of the pattern. Right now, because we're using the V ramp, maybe I'll switch to U just to see a little bit of more of the difference. It's very easy to kind of work with because there's a lot of output that you can work with, and you can also switch from this to other types of textures. I actually quite like the ones that get a bit tighter, and then within the intersection of different colors, you can actually see more variety arising. Let's go into our UV coordinates. Let's see. I'm going to, in my repeat UV, I'm going to increase the V to 10 maybe, and U maybe to 6. This is looking quite good. By rotating the frame, you can also try to affect it further. You can see in the back how it's rotating. It kind of makes sense with the way that the texture is working as well. That's not bad. And usually what I like doing when this is done, basically whenever you're kind of using texture deformer, it deforms in the way of a normal, but that only means that it deforms like in a one direction, like whatever the direction is. So you end up like with something that oftentimes looks like quite spiky in a sense. Let me try to just increase the noise a little bit, just so we can have something nicer. Oh, this is not bad. So you end up with something that's looking quite spiky, which doesn't always end up being very pleasing, I think. So I'll Control D to duplicate this object because I want to create like a static version of it. It will be unchanged even if I change the texture. And by going to face mode, taking all the faces, pressing Shift and right click and transforming component, you can push it out a little bit, which I think usually gives it quite a nice effect where like these kind of bulk up a little bit and just feels like a more more like tensioned object rather than the one that looks kind of like chiseled or sculpted. This one tends to look a little bit more like modeled, like a bit, gives a bit more of an organic feel to it, I suppose. So let's see, in this, if we switch this to none, it's also like, obviously, it doesn't work as well because it's quite a sharp decline between the white and the black. But maybe bump actually gives us a nice outcome. It's good to see in the sense that it's like very easy to update, so you can kind of see quite quickly differences between outcomes. And obviously we'll work with any other 2D texture. So whichever one you're using, regardless, it will work in a similar way. What you would need to do is kind of create different opportunities for it. Because right now DAG objects are off for me, I can actually go into my search and search for the texture deformer. So just type in texture deformer. This is the one. So if you select the node, you can actually affect it immediately. Right now it's linked to an existing ramp map, but it can be linked to something else. The way to do it is to hover above texture, right click it, and then break connection. Your object will pop back to its original position as it was before. And then in the checkered map, you can choose something else. So all 2D textures would be acceptable. Different ones have different outcomes, but let's try the noise one. Noise one is quite interesting because you can, again, affect quite a lot. Amplitude would also affect like the amount of give that it has, like in terms of extruding it. Maybe we can also consider changing the, let's say the mapping, because I'm not quite satisfied with this direction here. So if we select the object and change the UV mapping, let's do planar again, but maybe switch the axis. So I've switched it to the x-axis. You can see that like the direction in which the map is applied is different. This was Y. Let's see Z. No, Z is not bad. Let's stick with X for now. So basically, in the whichever texture you have needs to be projected onto your object somehow. Now it's being projected in the X direction, which is why you're kind of seeing it more flat in this side and more like accurate to what the texture actually is on this side. So now we've applied the noise texture on top of it. We can also search for that by just typing in noise and then like tweaking the noise a little bit. I think we can get away with the depth being lower because we have more. Whoops. That's better. You can also change the type of noise. Like there's different ones. Wave, below E, USB. I think wave works quite well. It's basically the kind of noise that you get for like a sinusoidal noise, and then different frequencies of a sinus curve actually intersect, which create a lot more of this, like, let's say, rich pattern. Let's actually go back to our texture deformer. There we go. And maybe even increase the strength a little bit. 3, 4. And the thing is that you can perform this operation on top of a live object as well. It's just that it might take a little bit more time to update. So if you select your faces and then shift and right click and transform component, and then move it along a little bit more. Maybe a bit more. It allows you to kind of do it live, but then usually in order to create like a nicer feel, it needs at least one more subdivision. So what I usually do is I select the object, press page down to make sure that there's no subdivision level applied, then press page up just once, and then go to 3. And even though it's a high poly object, you say yes, and then you see like the final outcome, which offers quite a lot in ways of like rich texture, just based on the deformer that we have here. Let's try the other one as well. So obviously, like changing the type, I think the wave probably is the most successful one. This was quite nice. So number of ways will obviously also affect it quite a lot. Maybe, oops, let's do 2. And every time you're happy with the object, the only thing you need to do to save it out is to copy it. The copy will no longer be affected by live changes within the texture itself. Let's reduce the frequency. Well, that's the same. So let's say 4. Again, easy to iterate between potential options. I think this one looks quite good. Let's just Control D to save. I'll move it out to here. Not bad. I think because there's a lot of competing geometry, I'm going to clean this up a little bit. Let's remove these. I think now we can take a little bit of a look into rendering out these elements as well. So the native render within Maya is Arnold. This happened when Autodesk acquired Solid Angle, which owns Arnold. So basically, whichever Autodesk product you would be working with would probably have Arnold now. 3ds Max Maya has it, so like I think the knowledge is quite applicable cross-platform. So setting it up in Maya is quite easy. I'm going to make sure that my outliner is clean for this because we'll be using it a bit more. And what we need to work with is basically our current render that's showing the viewport is the viewport 2.0. This is the basic render used in the preview in Maya, but you can also switch it to Arnold. This will open up a little dialog box, which allows you to kind of run a real-time render that can be previewed in cycles. So if you were to play this button, there's quite a lot of objects, so it might take a moment. At first, it's all black because obviously there needs to be a light source in order for Arnold to work with what you have in the scene. When you hit stop, it will stop rendering, which will make it lighter again to like move around in the scene. But in order to add, okay, so how would you recommend to export Maya geometry to 3ds Max? I actually think that it's quite good to just use OBJ. Although there is one really good way of doing it, and it's actually excellent if you're working with low poly modeling. So Maya is live linked to 3ds Max now. So even if, let's say, you have an object that's lower poly, I'm just going to create a box for the purposes of this. Obviously, like if you go to 3, it's smooth. If you're in 1, it's not. But if it's still available, and I think it should be, I think they've removed it, but there was a live link to 3ds Max that you could just send directly like right now I can only see sent to Unreal and Unity. It might be that it just needs to be loaded. Export to a file. The best way otherwise would be to use OBJs by transforming the smooth objects into smooth versions of them. So basically this could be modified. So you modify it, go to convert smooth mesh preview to polygons, and this object can be taken into Max as an OBJ. So it doesn't rely on like the smooth version of Maya. But I was convinced that even in more recent versions, there was a live link to 3ds Max. Don't know where it went because it was usually apparent. Let's see, plugin manager. It might be that it just needs to be 3ds. Seems that they've removed it. It's quite disappointing because I have used it in older versions. Just see. I'm 100% sure in 2018, if you wanted to do it, you would go to File, Send to Max, and that was an option that was available. I don't understand why they removed it. Kind of seems weird to do. This will live link your scene from Maya to your scene from 3ds Max. You could constantly populate objects from Maya directly into 3ds Max and choose which ones you want to sync and which ones you don't, which made it really easy. And actually it applied a modifier of open subdiv modifier within Max that made it very easy for you to kind of keep objects low poly and just use it as a modifier that kind of adds subdivisions on in Max that you can easily mute on and off, making your scenes very light. No clue why they decided to discontinue this though, because it was awesome. Very annoying. I will definitely look into this because I actually use 3ds Max as well. It didn't occur to me to check it for the new Maya. So like I was saying, in order to use Arnold within Maya, we also need like a light source of some sort. The most basic light source is a sky dome. So if you go to Arnold and go to lights and go to sky dome light, it will kind of populate this like large sphere into the scene. It will just be general, what's it called? General illumination within the scene. So everything is a basic material right now. Actually, apart from this one, which was used in order to deform, so it ended up having a material attached to it. Everything else is like a basic Lambert material. Like it doesn't really have much interest to it. It is what it is. Like there's not much change. I think what I would first add into the scene is a ground of some sort. You can see that while the materials are basic, you can almost model and move around while having the Arnold render turned on. That probably won't be possible as you kind of start building up your scene with more objects and with more materials, especially more costly ones. But I usually would kind of add in a plane in order to kind of make sure that we kind of get the depth right and the environment really nicely done. I usually just kind of create an extrusion. So this is actually trapping everything inside. Switching to edge mode, double clicking the naked edge so that you select everything around, and then just shift and moving in a Z direction, or rather in my the vertical is Y. You can also make sure that this background doesn't really affect the objects inside by selecting it, navigating to the attribute editor of the disk shape, and then in Arnold, making sure that it actually doesn't cast shadows. So you actually don't want it to affect the objects just beyond being like a simple background. I'm going to turn off my grid because I can still see it here where the nucleus is. You can do it by unchecking the grid from your ribbon above your viewport. And I'm going to pause the render for now. So with these objects, I think like let's kind of start working to create interesting materials as well. The good advantage of using Arnold is that a lot of materials are actually preset, which kind of works really well. So let's select the first object. if we hold down right click and then assign a new material, we will now be assigning the standard surface. The standard surface is a material that's linked to Arnold. It's the most basic material, but then you can have different layers within it that you can affect, which have a different type of contribution to the material of the object, which relate to, as you can see from the drop-down menus, to the base color, specular color, transmission, subsurface, coating, sheen, emission, and so on and so on. So in order to kind of see it a little bit more clearly, because especially when you're kind of updating it, it might be annoying to have it selected. I again would use my outliner, unchecking the DAG objects, navigating to the latest material that I've created, which is material surface 2. Maybe call it, I don't know, maybe this one can be transparent. And then playing the Arnold viewport. And then we can update the material and see how it fares. So we can either do it like manually, sort of trying to figure it out on our own. However, like I said, luckily there's something in presets that also allows you to apply like a custom material with preset options. So let's say that we want this to be glass. So we will just go to presets, glass, and replace. It applies a glass material on top of this object immediately. It's kind of tough to see because the glass is also now solid. The object kind of assumes that there's like a solid block of glass rather than a thin film, which is, I think, what would work better for this object. So it's important to also, if you want this glass to be like a transparent film, almost like foil, in geometry, which controls this material, you need to thick, thin-walled. In this case, it actually treats it as like I said, like a very thin film rather than a solid block of glass. It's not like a snow globe. In order to kind of edit this further, the transparency is controlled by transmission. This is basically a refraction for other people who use like V-Ray or something. Like this is essentially what refraction is. If you lower it down, you will see that the opacity or rather the opaqueness of the material is kind of going up. So it's becoming kind of easier to make out the shape itself while still retaining some semblance of transparency. Changing this color also changes the quality of the color of the refraction as well. I'm going to change it to something a little bit more pleasant than this yellow, maybe something orange. If we wanted to control the amount of, let's say, shininess, or how whether this was shiny or it was like a rough material, you need to go to specular. Specular roughness for glass right now is 0 because glass is like crystal clear, right? But if this were to increase, you'll actually see that this is slowly becoming more like frosted glass almost. So the bigger it is, like the more difficult it is to make out whatever it is that that is behind this object. So you can kind of see that it's starting to like create like murkiness to the object itself. The more you increase it, the more it's difficult to make out what's behind. And on top of this material, I'm also going to add coat. Coat is basically, as the name suggests, something that almost sits on top of your material, and it has a lot of the properties that the base and the specular layers do, including the refraction. So if you kind of reduce it a little bit, this material is a bit of a nonsense material, doesn't really exist, but I think it kind of gives it like a nice shine to the outer lying edge of the transparent material, which makes it pop even more. So if you just keep it like under 1, you would actually end up with like a nice, nicer result, I think. Okay, so we have one transparent material. Let's try to give some attention to these flowering elements. For now, I'm going to freeze it and then assign a new material. Again, a standard surface which we will call SSS. So SSS is like a subsurface material, subsurface scattering material. Anything that's like jade or wax or something that kind of, as an object, you see it and it's sort of, there's like this almost rim of light to, even though the object is thick, because to a certain point, light does penetrate into it until it becomes so thick that no light can, filter through anymore. So if you kind of put a candle up against the light, you can actually see the rim edge or the rim light on the candle in the areas where the candle is really thin. This is what subsurface scattering actually is. It's really costly computationally, but it produces quite nice outcomes, I would say. So in order to add it in, there's a subsurface layer within it. You can just crank up the weight all the way up. And you will see that like there's almost like a murkiness to these elements now. There's also some preset colors that work really well for different materials that do exhibit a level of subsurface scattering, like not least of which is skin. And you can go to color here into the drop-down menu, which you have from like these 3 lines. And you can just choose one of the other ones. So because this is like an object, obviously, that's like made of really thin sheets, it can be a bit difficult to visualize it properly with subsurface scattering because it has no volume. But by changing the scale, you kind of can affect a little bit more the rate of transparency, which kind of makes the object pop a little bit more by making it less transparent, but also giving this still this, let's say, effect of subsurface scattering, because you can actually see that towards the rim, it kind of goes grayish, where the material is almost assuming that this end is quite thin, even though the thickness of this object is kind of uniform all across. I've switched it now to smooth mode because I didn't quite like the edging that was showing up. So just basically selected all of the objects within the group and pressed 3 to kind of have like a smooth version of it. In order to control how much quality you're exerting, or like how much stress you're exerting on your PC while you're doing these like test renders or renders that are just kind of checking against a certain quality of light or material, you can go to render settings, which are in your ribbon right above like the main ribbon of Maya, and it has like display render settings prompt. I'm going to stop them for now and then open them up. By default, they actually are set up in the sampling part. You can kind of kick the sampling way down in order to get something that's a very rough version of it. Like, it's super rough, but it kind of gives you a general impression of what you might be working with. And it's just slightly faster than what we had before. So for like test renders or test looks at what this could give you, I think it's quite enough. Let's add our SSS material to this one as well. It works really well with geometries which have quite a lot of deformation, because it kind of, I think, accentuate the deformation quite well. It looks really nice. Let's add a little bit more into this, the separate material to this one. So again, I'm going to stop the rendering process. I'm going to take this one, assign new material. Again, we can work with the standard surface. And with this one, let's do something that's a little bit more opaque. It does not need to be transparent like everything else. So let's make it pop by leaving it a bit more opaque. We can see, for example, that in this one, the one where we kind of deformed the cloth by using texture, there's already a texture applied, which is where the certain patches of dark come in or come from. This is actually our ramp number 1. It had to be grayscale in order for us to control it or use it for controlling the cloth itself. But we actually don't need to keep it grayscale once we're happy with it, how it looks, and we just want to actually work with coloring of the material itself. So in presets, you can quickly change that from black and white into a rainbow setup, which will create like this kind of rather intense distribution of color. I think like with tweaking the colors a little bit, we can have like a nicer set of colors that relates more to the rest of the setup. Maybe this hot pink is a bit intense, but the yellow could chill out to a little bit more cream color, and maybe the pink I will also change. That's not bad. The current material that is applied is a Lambert material. It doesn't work as well, and you should just use standard material anyway, because that one is kind of fine-tuned to Arnold itself. So if you select this object and then you like scroll through, eventually one of them will, one of the cards in attribute editor will actually give you the material that is attached to the object itself. Right now, the type is Lambert. You can kind of force transform it into a standard surface. It will cause the map to unlink from it, but since we know where the map is and we know that the base and the standard surface actually refers to the color of the basic color of the object, it's quite easy to just take this ramp and like drop it back onto the color. The weight part determines the amount of contribution of a certain layer to the material, but the color itself determines what the quality of that color is. So, for example, in specular, or rather in transmission, the bigger the contribution to transmission is, the more transparent the material will become. But if the transmission is not full, it also uses a contribution from the base in order to color whatever is happening here. So I think that kind of makes it quite easy to understand. By increasing the metalness, I mean, a lot of this is very logical. It kind of suggests what it already probably does. Creates like a more metallic material finish to it. The metallic finish can also be controlled the same way as transmission can be controlled with the affectation of the specular roughness. This will actually make it seem whether the material or like the metal seems more like a brushed metal or like a high polished, very shiny metal. Obviously, the lower this value is, the more this will look like basically like chrome. So we want a little bit more roughness because chroma looks a bit too much like it's clashing with what we actually have here. I'm going to also apply a very basic skin material to the base mesh underneath. So I can assign a new material, go to standard surface, go to subsurface, increase the contribution completely, and in color, maybe add skin 1. Let's see how that looks. This standard surface 6, I can rename it to skin. Not bad. I do think that this metal one is not working as well, so I'm just going to kick it down a notch. Let's remove the metalness from it. Maybe if I add, perhaps a coat would be enough. So a bit of a coat with a lower IOR. Yeah, that does not look as bad. I think these ones can remain transparent. Definitely not a fan of this one. I'm going to change it up a little bit more. Let's increase the transmission. For the transmission, like if you increase it a lot, like you will eventually lose the color, but I actually think that a very easy way to restore it, obviously, is to just use the color for the transmission color instead. It's a bit extreme. So let's reduce it a little bit and make sure that the roughness is low, because we want whatever is underneath to be coming across quite easily. So for example, if you're finding yourself to be like kind of happy with what the result is, but you want to like make sure that what you're actually seeing looks a little bit better, it's probably the time to increase the samples and let your computer struggle for a little bit longer, so you have a little bit more of a realistic expectation of what the output might generally look like. Let's just give it a few minutes. Not looking bad. Yeah, the color scheme is not so bad. Let's apply some of that also to the other mannequin. So this can be skin. These guys could be probably the last one. I'm going to bring the samples down again to 2. That was quite funny. I think it would be better if I assign a new material to this. I think what actually works especially well with, let's say, animation snapshot type objects, because they're kind of already separated in a very clean way for you. It might be nice to actually apply material, a couple of materials that kind of delineate it a little bit better. So what I would do is like go to the object group, find it here. We have 20 objects. Let's go in increments of 4, assign a new material. Let this one be, let's see, this pink, and then new 4, assign another material, standard. This one can be even a stronger pink. New 4, assign new material, standard. This one can shift a little bit to purple. New 4, material, standard, and this one can be almost yellowish or golden. And then the last 4, so new material, standard surface, this can be a cyan. That actually looks quite reasonable. And then for these, I'm going to apply the transparent one. Whereas these, we can apply, pretty sure 4 was a basic material. This is why naming is important, because it makes it so much easier if you name it properly. Not bad. And these shoes, can apply new standard surface material with subsurface. And let's make it skin 2. The reason why one of them is probably black is I'm assuming that because it comes from a mirrored object. Mirrored objects have flipped normals, which kind of messes with certain materials that are dependent on like proper orientation of normals. You can check that out if that's the case, which I think it is, just by selecting this shell and then going to mesh display and then reversing. A good way to check also is just to uncheck two-sided lighting. Yeah, that fixed it. So two-sided lighting is obviously like a good way of keeping track of this, which ones are actually flipped versions. These ones are like that only because their textures are in fact transparent. So might prove to look different for other reasons. Not bad. One more thing that I think is quite useful within rendering in Maya is that it supports render layers. This is really great, especially when you're working with like a complex model with a lot of parts. So what you would actually end up doing is, if you render out either a sequence or a still image, you might want to like further edit it in Photoshop, and you might want to have access to elements within the image in like a color-coded way, almost like an object ID pass. Render layers can really help with that, especially because they can be used to color code objects and then give you an opportunity to kind of work with the object a little bit more in a more controlled manner. The way the render layers work is that you would actually be able to retain all of the distribution of materials that you already have with these objects, so that the materials that you have applied are working well. But in a separate layer, you can apply a whole other host of materials that will not break the original hierarchy, but will allow you to export another pass, which will make it easier for you to composite later on. So the way that it works, close to your render display settings, there's first a hypershade, which will contain all of the information about all of the materials that are in your scene. I kind of avoid using it unless I'm actually building a network of a material here, because I like accessing things from the outliner. But you can get it from here as well as kind of develop the entire network of the material. So you select one material, and if you select inputs and outputs, it actually tells you everything that's being used. So it's kind of like a editor for any kind of Max user. I think with V-Ray, it works pretty much the same. It's based on wires and like batteries, kind of like Grasshopper as well. It's quite good for building complex material. But next to that, you actually have something that's called render layers. So in the render layer setup, right now there are no layers. There's only the master layer that we're using to create all of the materials within the scene. So if I added the new layer, I can call this one ID layer, for example. So every layer will work the same way as it does in other software. Like when you have layer for like sorting objects, this is the same, is just that its focus is actually sorting objects based on material. So if you right click it and create a collection, the collection expresses like which objects do you actually want to be included into this layer, because you can also affect membership, right? So I actually want everything to be included, because I just want, well, maybe not everything. We'll just take these two guys and the background. When you just select them, you can hit add, and they will be added into the collection. And then your collection can also have create a shader override. This shader will be applied like uniformly to every object, unless you change a material within that layer later on. So the shader override that we want, we can kind of open up this little checkered box here. And in Arnold in utility, or rather in shader, there should be something called AI utility. So AI utility basically will exploit a certain property of the object and then create a render based on that. So shade mode, you can leave for now. Overlay mode should be none. Color mode, that's where we can actually choose a certain property that we can use to kind of create a value of a color within the material. So what I'm going to do is I am going to choose object ID. And in order to kind of see what this looks like, you need to go to your render setup, and your render layer by default will be the master layer. You need to switch to the ID layer. You will see that once I've switched the ID layer, actually everything that's not included into this layer will go away. I've only included these elements, so that's why they're visible. I'm going to close everything down right now, just for a second. And I'm going to save the scene, just in case something goes wrong. And then in my render, I'll switch to Viewport 2.0 and then back to Arnold just to see this dialog box reappear. And I'm going to hit play. Might take a moment to compile. And actually what you end up seeing is like color coded based on the object. So and every object has its own color. And right now it's kind of giving you this like slightly shaded, kind of tries to express the deformation of the object, which is actually not useful. What we actually want is for these to be flat renders. And instead of a shade mode being n.i, you just change it to flat. And this will essentially become like a masking layer that you can export along with your follow-on render, because in that way you'll be able to access different objects. And then whether you're compositing in like Nuke or After Effects or just compositing stills in Photoshop, this is like a very useful tool to have at your disposal, because you can easily like just use tolerances of a certain color to mask something out or mask it in or change its color, change its texture or whatever else. So this is a pretty neat layer to have. Another layer that I think can be added is a toon shader, especially if you're trying to look for something that looks more like it's kind of like a sketchy render, or if you're looking for a render that's less computationally costly, but actually creates like a nice concept render to communicate like an animation or even just like a still image. Toon actually works quite well to like give you that extra level of like almost hand drawn render. So I'm going to turn off this one for now, go to my render layers. So this, we will create another render layer. I will call it toon. I'll select all of the objects again, which we have in this layer. That's good. And then again, like before, create a collection, add objects into the collection, go to the render setup, switch from my ID layer to a toon layer, turn off everything. And then in my render setup or layer setup, I also need to create an override shader, right? So I will create a shader override, click the checkered box, and then type in toon. We'll give you the option of AI toon. If you click it, it creates a new shader, which is a toon shader. We've switched everything off, right? Good. Control C. If you play it now, oops, that was my mouse. If you play now, what you will get is just like a flat ambient, almost like an ambient occlusion render, which can be a bit confusing, especially because it's supposed to be a toon layer. But that's because the filter mode also needs to be changed. So in your render settings, there's something called filter, and it doesn't work the same way that it works if you're using the Gauss or the contour mode. And what the toon shader needs is contour mode. So if you go to your render settings in filter, type Gaussian should be switched to contour. This will enable you to actually render out contours of an object. Toon shaders are quite editable and I think quite nice. Obviously, like the scaling is sort of dependent on the zoom. So depending on how much detail you want, it might be also nice to just reduce the edge scaling. By default, it's 1. If I put it to 0.25, it kind of will go down a little bit. You also want it to still show up. This is maybe a bit too thin. 0.5 maybe would be okay. Yeah, that's not bad. Still has some presence. It also renders quite fast, and it kind of just expresses geometry a little bit better with just a little bit of that stroke that is being added around. You can also enable silhouette, which can be a separate thickness to it. So the silhouette will kind of further like enhance like whatever object it has by adding a silhouette around it, which I think works quite well. And Toon shaders will also support other aspects of the shaders that we've already seen. Let's just tweak this. That's not bad. And then obviously for the base, you can change the tone map if you like, but even if you add like specular, it will also like try to shade the specular, like the reflections that your objects will have as well. Obviously roughness will affect that, like it will no longer be obvious if it's like not super shiny. I think something that's quite nice is sheen. It adds a little bit of almost like a rim light in a sense. So if you add a little bit of a color or a tone to it, I think this is fine. Kind of almost as like a halo disc of this color around each object almost on the rim of it, on the edge of it. And I think like this kind of creates layers that are quite useful for compositing, like I said, because it can cycle between like sketchy version of the render and like a very hyper realistic version of the render as well. Let me just close down these spaces. So it with render layering, it kind of gives you an opportunity to have a lot more control over how your render turns out. Let's go back to our master layer for now. Master layer. I'm going to like hide anything that we don't actually want. Again. Take a little bit of time to compile. And I'm going to switch from my filter mode, which is currently contour, to Gauss. So, okay, we definitely don't need these either. In terms of like adjusting the lighting a little bit, because the general lighting that I'm just using now is quite boring. Like I think it could be made a bit more exciting. The general sky dome light is just general lighting. I'm going to hide it. Right now, if I play it, there's no light source, so there's nothing appearing. However, we can also use different Arnold lights in order to create area lights that will light up the object a little bit more nicely in a localized manner. So I have a light here. I'm going to position it just above the objects. If I play, right now you see nothing. If you go select your light and go to attribute editor, you need to uncheck normalize, which will make the light brighter. And you can obviously control the intensity of the light as well as the exposure, which will amount to like more light in the scene. Using color temperature allows you to like switch between a warm and a cold light. I think I'm going to go for something a bit warmer. Stop this and save. And obviously, as many of these light sources as you like, you can introduce. I'm going to switch it to a disk. And then add a few more light sources. Just to add more interest. Oops. Wrong play button. The reason like it's appearing like this right now is because I've used this file before and I have unfortunately forgotten to remove one option, which I will demonstrate right now. So I'm going to delete this just for clarity's sake. Let's go back. So I'm just going to restart my Arnold. The effect that you saw was basically an atmospheric effect. Like by default, when you kind of introduce just lights in the scene, they kind of just work with whatever they have there. Like they bounce off the objects, the lights kind of create for themselves like an effect on these objects. But what you can also do is have the environment itself catch the light in a way, which is usually referred to as volumetric lights. So in a sense, what you can do to achieve this is just set up an atmospheric effect. Sometimes Arnold gets a bit buggy with this, which is why it like showed up and then disappeared. So I'm just going to create a completely new atmosphere volume. So you need to open your render layer, render settings, go to Arnold Renderer, and then go into your environment. Right now you have an atmosphere and background. In atmosphere, if you left click your checkered box, you can create AI atmosphere volume. This volume has some form of density. You can start with a very low density, like 0.001 is completely fine. And then you open up your Arnold render, and hopefully now it will link correctly, because I might have confused it a little bit. Oh, it's linking correctly. So you can actually see that the light is being caught into the atmosphere itself, which is why the lights are becoming a bit more visible. The more contribution you allow, the more light will be caught into the atmosphere, and gives it this like almost misty type feel, which I think works quite nice a lot of the time. Obviously, you can affect the color as well. The way that you kind of work with different colors will inform how this might end up looking. Attenuation will refer mostly to like the rate of decline, in a sense, I suppose, within the rest of the scene. I usually like to kind of keep it, let's say, like this, so that in a sense that the environment appears cold, whereas the light itself can appear quite warm, and you can increase its intensity. Let's do the same with the other one. Make it a bit warmer. Increase intensity. I'm going to move it out of the way a little bit, because actually when we're close, I don't want to see the traces of it. And now I think also my atmospheric might be a little bit too intense, because we also want to see this a little bit better. Good way to control this as well is like to determine the amount of contribution each light has to a certain layer. So if you select your light and you go to your attribute editor and scroll down, there's like different contribution that this light has to different objects, including volume. Like you can use a light to light an object without it actually being, without affecting the atmospherics. So for example, I can see that this light, I've now killed the volume. But if I increase its intensity or exposure, it's still lighting the rest of the objects quite well. It's just that it's not contributing to the volume light at all. And by controlling how much you contribute, you can also control like the legibility of the render, in a sense, which I think works quite well. Another good way to control area lights is to affect their spread. The spread of the light actually kind of affects how focused it is. Think of it as like cycling from like a really harsh spotlight to like an area light that we see here. So obviously the larger the spread, the more it kind of affects. The smaller the spread, the more focused the ray of light will be. And the more focused it is, like the less intense it really needs to be honest, because it's focusing on a smaller area. I'm going to play around a little bit more with the atmosphere. Maybe even try to change this to a colder atmosphere. Maybe not as cold. And then increase contribution. That's not bad. So obviously tweaking the amount of light that you have in the scene will also change the mood quite dramatically. That's not looking bad. So once you're ready and you feel like the setup is kind of okay and you're happy with what it looks like, obviously it's time to kind of crank up the samples. I think really 2 should kind of be minimum at any time. And camera AA, the first one, is basically the one that kind of increases samples like across the board. It sort of gives a little bit more of an edge. The bigger it is, like the more it will affect all of the layers. The other option is that when you have materials that don't necessarily use transmission or SSS or volume indirect, it's easier to keep those samples really low. It might help your computer be a little bit more successful, let's say, in rendering in a faster time frame. Let's move these a bit around because I'm not quite happy with the setup. Add just one more light here. And maybe kill the attenuation just a little bit. That's not bad. And with our lights, just change the temperatures a little bit. Mix of temperatures works quite nicely. Not bad. So once you're ready kind of with what you have as a render, and this is like light-wise, I think is an okay setup. In your common tab in your render settings, you can like prepare for actually exporting like an image. Image format, up to you. I use JPEG usually. Right now it's a single frame because it's just a still image. So this setup is correct. You don't need to change it. And the most important part, of course, is the image size. So I'm going to stop the render or like the viewport render. I'll change the preset to a full HD. You can maintain width and height ratio and then like crank it up easily to an ultra HD if you need to. And this is kind of okay for what you have in the main tab. And then in Arnold, you can open Arnold render view and then just play it out. And now we'll attempt to basically render the entire scene at the maximum resolution that you've set, along with the samples that you've set in your Arnold renderer tab. I think by default, you can also use it as a progressive render. Sometimes it's nicer to just kind of quit at any point, I suppose, while having like a decent enough image. So you can kind of see the outcomes. A bit confused in the color scheme, but not bad. Like the lighting seems good. I think what I would also add, and it's kind of like a nice opportunity to light your scene in a bit more of an exciting way, I would say, is that you can also transform meshes into lights. So for example, if this mesh were to become a light, you can just select it, go to Arnold Lights, and turn it into a mesh light. It will no longer be visible. You can increase the exposure and the intensity a little bit. I'm going to use color temperature as well. Maybe I'll make it cold. And then in Arnold, if I play directly from the viewport, it shouldn't be visible, but it should contribute somewhat to the lighting within the scene. You can also make it visible by clicking light visible and unchecking normalize. Okay, now it's out of control, let's say, but exposure needs to be probably around 1. We can keep the intensity. And maybe let's make it warm after all. But it kind of creates a nice opportunity for you to control the way that the light kind of hits your meshes, because you can also model a light in the way that you want it to be introduced into the scene. And you can always release that light from the mesh if you want to get the mesh back. Also, the mesh light will always be applied essentially really to like a flat version of your object. So if it's like a low poly object, you would need to subdivide it. Okay, let's do a render. So now we have this set up. This is looking fine. Maybe let's reduce this a little bit because it's a bit much. Render view. To aid you in like setting up your render view, it's also not a bad idea to turn on the render gate. It will actually tell you the portion of the screen that it will render. The render gate is located on the upper ribbon from your viewport. Is these little rectangles with dots inside. And it should correspond to whatever comes out here based on the resolution and aspect ratio that you've given it and position in space. So let's see. Not bad. You'll see the progress bar in the lower portion of the screen. And you'll see how it's moving across time. Okay, I think we have like a couple of more minutes left. I don't know. Do you think, Mike, that it's worth doing a Q&A, or should I just continue showing a couple more tricks with Arnold, or like the export settings and stuff like that?
It's up to you, really.
It would be nice. I think like if there are some open questions that, or some comments that people might have, it could be nice to like open the possibility for that, if someone is interested in sharing some thoughts.
Sure. Does anyone have any questions right now? I don't see I don't see any new ones. Or do you have anything else that you want to show?
Could do in the last, I think we have 7 minutes, so what could I show?
It looks cool, by the way. Really awesome. So,
thanks.
Yeah, if anyone has any questions, or they feel like asking a question on camera or voice, you can raise your hand. You can put you on camera or voice, or you can ask it in the chat or Q&A if you're
Seems like a quiet bunch.
feeling a bit more shy, or if there's something specific you want to see else.
Yeah, we have another 5 minutes. Why not?
Yeah, if there was anything else anyone's interested in seeing or seeing more of, please let us know. Or, yeah. I guess everyone's satisfied.
Guess not. Okay, so I mean, I guess like
they're very quiet today.
yeah. Does this geometry work in Blender too for rendering? Thank you for the yeah, you could, as long as you export an OBJ file, you can just import it anywhere where you would like. It can be a Rhino, it can be Blender, it can be 3ds Max. OBJ will basically take any geometry file from Maya, and you can like transport it anywhere else that you would like.
Anyone else? Take advantage of the time we have.
PBR materials. I'm not sure. Do you know what the question means? What are PBR materials? Maybe I just don't know the abbreviation.
Yeah, it's like for game. Yeah, it's like video, like game material.
Or like pre-light materials, or
Like it's slipping from my mind. It's like photorealistic kind of materials.
okay. Well, I mean, obviously it depends, I guess, on the kind of engine that you're using. Arnold, it doesn't have to be Arnold. V-Ray is probably much better at handling certain requests in this sense. So you can use V-Ray in Maya. It's just that I natively use Arnold because I'm very lazy to find another engine. I'm not sure how much it would make a difference, but I do think that, like, in general, V-Ray is better. So maybe it's a better bet than Arnold. I'm not sure that Arnold could handle it in the same way. Okay, guys, 4 minutes, 3 minutes. What is there anything else? Hopefully. Comments, thoughts, questions? Nope, quite a bunch. Okay, so I think,
Things
like,
you can do PDF, like PBR materials you can do.
yeah,
Yeah.
good to know.
Google search there. Just put it in the chat.
Yeah, final comment then. Once you're ready with your render, file, save image, and straight to Photoshop. And you can also, like, render out all the other layers as well to, like, aid you in working with Photoshop. If you, for whatever reason, created an animation, which is usually what Maya is for, to be honest, you can also switch your frame animation extension to name underscore and hash key. And then instead of rendering it through the Arnold render view, you can switch to the render tab, go to render sequence, choose the appropriate camera, and choose the output file location, and then just render sequence. So if you have like 20, 30, thousands of frames, that's how you would do it as well. And you can also give a frame range to your render settings. So if it's not still, this is how you would do it. Because you can obviously animate cameras, animate objects, things can change over time, and so on. Okie doke.
Well, that was well, that was a awesome webinar. Really cool workflow.
Thanks.
Looking forward to see more crazy stuff in the next masters as
Yeah,
well.
that'd be great.
As we add and it's going to be really cool. First one was so awesome, like all the stuff they were doing with the characters.
Yeah.
Cool. So yeah, as usual, recordings will be sent when they're ready, and certificates as well. And yeah, until next time. And don't forget, if you're interested in the masters or CDNX, you should go check those out and sign up for them soon.
Okay, thanks everyone. Hope you enjoyed
Thank
it.
you all.
Bye.
See ya.